Hello, everyone. Welcome to the AI Tomorrow track. Excited to get things kicked off. It was really fun to just have the keynote from Guy, where he spoke a lot about kind of starting with the history of how we've gone from kind of code completions to chat to agents, which is all the rage these days. And so I'm particularly excited to kick off the track, kind of taking that from a high level and going deeper with it. So I'm going to be bringing on Itamar Friedman, who's the CEO and co-founder of Kodu, and he's going to go in and kind of share his insights on multi-agent workflows and what he's learned from all of the developers on their platform. And so let's welcome Itamar to the stage. Itamar, nice to see you again. Welcome.
Adrian, pleasure being here for a second time. I'm really excited to see how this community evolves.
Yeah, totally. Are you joining us from Israel again? Is that right?
Yeah, that's correct. I'm moving to New York late July.
Oh, nice. Congrats. Fun. You'll be I live in Boulder, Colorado in the US, so I'll be able to see you stateside.
I'll get there when I get to later on in the career.
Yes. That's awesome. Well, thanks so much. Again, really excited to hear what you've got to say. And so I want to jump off stage here so I can listen in and learn from your latest rendition of what you've been learning on the agent side. So let's get your slides up and take things away.
Awesome. So continuing, Guy, I'm in the tomorrow track, right? Although at Kodo, we very focus on today and tomorrow. I might mix a bit of some of what Kodo is doing today, but I am here to entertain for what's coming tomorrow. And I will continue from where Guy left it, but I'll iterate it a bit in my point of view. So Itamar Friedman, the CEO and co-founder of Kodo, formerly known as Codium AI. There are a few Codiums, each one took its path. And I'm here to talk from code completion to multi-agent workflows, where I'm going to try to convince, although I don't think it's that already futuristic, saying that multi-agent workflow is the way to go. So let's start. So if we're looking on the AI for devs world, and on the x-axis, we're taking the knob and the enterprise developers, that's maybe the one that cares the most about, for example, quality and all, maybe in generation and creation, then I think that Gen 1.0 was the autocomplete moment. It's actually quite old, quote unquote, with players from more than 9 years ago, but I think it had its moment with Copilot or by GitHub Copilot. And I think what we saw is that people that already know how to develop, they really like this autocomplete. They could achieve more. And maybe the extreme, the right side, maybe the autocomplete was a bit annoying for them for a long while, but the majority of professional actually helped them to achieve more. And then came Gen 2.0, which was the chat, and even 2.1, the agentic chat. And then I think people started to love the technology, the user experience, etc. And I think also that less professional people could achieve much more. Before that, when you had the autocomplete, maybe English to code was already possible, but less than what you can achieve with the chat or agentic chat. And I do think for some, of course, I'm generalizing, for some of the professionals, actually the idea that you get from chat, you get a feature, actually introduces some risk or some inefficiency. You get a lot of code, then you need to review it, etc. Again, I'm not talking about the future right now. I'm talking about the current state of intelligence coding, let's call it like that, right? And then I think what we're going to see very soon, we're seeing already early birds, we're seeing early adopters, companies that are and products and open source. We're coming with the Gen 3.0. 3.0, and that's end-to-end workflows. And I'm going to talk about it a bit later on, what it means. Okay, and I believe that we're seeing game changer moment in intelligent software development. Basically, the autocomplete moment in a chat and agentic were, let's say, amplifiers for developers in the way of they're assisting you. And once you're moving to end, then basically they're becoming team members. It's still really, really early, and we're going to elaborate about that a bit. So the phases, if I summarize, first we saw like ID plugins, right? And then what we saw is the ID forks, right? You all know what I'm talking about. And what I'm trying to say here is that they're all assisting you where you usually write your code. And when we're talking about end-to-end workflows, then we're also talking about AI across the SDLC. And that's where I believe you will see companies that are, and products, et cetera, that are building for the end-to-end workflows, not necessarily only in the ID. I'm not going to talk too much about Codo in that respect, but shameless plug, this is exactly where we focus at. Okay, now I didn't mention here, like vibe coding. I feel ashamed, like I'm talking for, I don't know, like 4 minutes or so, and I didn't mention that, right? So let's talk about it a bit. Andre Karpati, I'm sure that you're all aware of. He coined the term vibe coding. Actually, maybe it's weird for some of us. It wasn't that long ago, and you can see, for example, that it strongly correlates to the Sonnet latest version, like 3.5 coming out, and then like tools like Cursor worked really well. But then there's other things that happened. I'm not sure if you're hearing the video, so I'm going to narrate it a bit. So we saw some let's say pushbacks or interesting opinions about what's vibe coding. So for those that are not familiar with vibe coding, I don't think anyone is here, but those that want to entertain themselves a little bit, let me narrate this video. So basically, I'm a developer, right? And I'm thinking, where am I in the code? I want to develop a new feature, right? I'm Alice. And then here I got to my rescue an AI assistant, and I'm saying, "Oh my God, here is an AI for developers, and I want help to, I don't know, like create my feature, and I'm asking for an AI to help me with that." Now, interestingly, the developer is asking where to go, and the cat is the AI is asking, "Where do you want to get to?" Right, and the developer is saying back, "I just want to complete the feature." Right? So the AI is saying, so it doesn't matter where you go. Let me take you through one path, one way to get to your destination of completing the feature. All paths lead to Rome, or the feature. It doesn't matter for you developers. I'll take you through one. But by the way, if you really like to know, you just got a bug there and there. Okay, so that's like vibe coding, and with that let's say feeling. We move on to some posts on X and LinkedIn that I noticed more recently, saying, okay, with two developers using vibe coding, you can do like 10x, 5x, 5x, 10x, maybe 25x productivity, but also 25x technical depth. And for me, it was shocking. I thought it was a bit exaggerating. I do remind you that like it does matter which kind of a developer you are, probably. And like as I mentioned, maybe some of the enterprise or most professional developers don't think that vibe coding is a good idea, and maybe that's like one example of such. And I try to check my own network, and I did on X and in LinkedIn posts, and I noticed that most people think that there is gain of productivity 5x, which is amazing for like two developers. And the technical depth, maybe I'm not clear here, but it could be between like just the same that it was before if it's 2x, or maybe 2x more than you would expect. But the majority are saying that there is productivity, although I didn't give an option for not, but also a technical depth that is growing. And by the way, on LinkedIn, it was a bit worse on towards technical depth. And here is like my understanding, like Codo understanding of the situation. The thing is that with simple software, like if you're starting a simple game from scratch, what's simple is actually the border of what simple is moving. It's a moving target. But what's simple, but for simple software, like code generation is all you need. That's the tip of the iceberg. But underneath, when you're talking about heavy duty enterprise software, you need also to relate to maintainability, code coverage, compliance testing, best practices, etc. Dealing with scale, don't repeat yourself. That's a very important concept for heavy duty software, which is really hard to get, for example, with vibe code or with chat interface. That's the claim of this, like, looking for tomorrow's session. Let me try to give another point of view for that. I think that the most basic part of the SDLC is like, I want to plan my code, the feature more accurately, and the technical spec, and then I want to write the code, and then or generate the code, and then probably I also want to verify its correctness and its standards, its scale, etc. So that's the testing and review part. We divide that into what we call the blue team. At Coda, we divide it to the blue team and the red team. Like, blue team is like where most code generation put their efforts and focus and with amazing UX, UI, and technology. We all fall in love with using that. Now, there is a small illusion here, is that plan and writing code is all you need. Actually, vibe coding to some extent is like iterating over these two when you're developing a new feature. It works really well. It also works with existing code, but it works really well when you have nothing from scratch, for example. But the thing is, in reality, especially in heavy duty, you're doing a lot of changing feature, refactoring, fixing a bug. And you also care that even a new feature would be tested and reviewed. And that the red team is something that we're claiming that we're going to see tomorrow. When I'm saying tomorrow, I literally mean like the next half of 2020, the second half of 2025, as well as 2026, being the next like exciting, let's say, value proposition of AI for software developers. Now, the thing is that I think a lot of the testing and review, they need to have really high precision. Basically, I claim if you vibe code them, then basically you didn't really like you didn't really complete the purpose of the red team. And having workflows doing the red team is very important. Again, I'm going to obviously cover it in a second, in the next few minutes. So what could be workflows? It could be completing a task end to end. Just an example, it could be completing a task, plan, write, test, review as one like workflow. And another workflow direction could be doing pre and post processing to enhance and verify. What? To enhance and verify a plan, to enhance and verify writing code, testing, review, or a couple or four of these or other parts of the software development lifecycle. And then the last option that I suggest for a workflow definition in our context, obviously, is like covering more than one aspect of the SDLC. It might sound like the same as the first point, but an end-to-end task could be, for example, finishing an end-to-end integration test or finishing an end-to-end review. And covering more than one aspect of the SDLC is like doing the testing, writing code and testing. And now, because of that, that's not mutually exclusive, all of these workflows, okay? My claim that obviously if we want to get to the third phase that I mentioned, that, like a game changer, do a lot of coding, not necessarily in the ID, and you raise the quality, that workflows are required, especially in the red team. Okay, so checking the time. Last thing, like to try to visualize it. Now, if you're trying to do like vibe coding and just like fixing a bug, that's something like you just give the LLM like try to fix it. I saw this meme. I didn't do it. Like, sorry for not bringing credits. It was hard to find, and that's what I heard from many developers, how they feel, when you're trying to vibe code generally and specifically like fixing a bug, and it could mean many things, like the bug is just waiting for you to hit you back, right? So that's like another interpretation. I saw many interpretation. And then really interestingly, continuing with this notion, really interestingly, I saw just recently, it's a few days ago, Karpati, the same one that coined the term vibe coding, he wrote that code I actually and professionally care about contrast to vibe code. The same person that was in charge, I think, on coining the term and getting a lot of excitement about some of the tools, and which has a lot of it's really amazing tools. Now thinking about it again, and he's saying that professional code that he professionally care about, I translate that the quality is important, maintainability, everything I said before about heavy duty software. That's how I take it. And then he starts to giving advice on how to deal with it. And he gave first advice around how to add a lot of relevant, or a lot is not necessarily, how to add as much as possible, or all the relevant context that you need to complete. But it's not the only thing. He gave here a full list, 1, 2, 3, 4, 5, 6. And that's basically a workflow. What he suggested is a full workflow. And I want to focus specifically on sub workflows around software quality and like bringing relevant context. And basically both of them would be around the area of pre and post processing. Okay, it's a big topic, workflows and multi-agent. I'm going to focus on pre and post processing to enhance and verify software development in the era of AI. So first, you see my theme around Alice. So let's say that you want to develop a feature, and the same feature that you're asking for, you're probably not giving it the full spec. If you write it everything 100% complete spec, it's basically as writing code. So you're probably is giving it, if depends on how much do you care about the path you take, you're giving it as instructions. But then even then, when you're doing vibe coding, you're letting the AI choose the path. Now the thing is that one path could be including considering SLA, architecture, best practice, scale, spec, and the other might not. These two paths might look the same, but actually it might look more like this. Like one is leading to the castle, to the feature from behind. The other is leading like through a dangerous place, etc. One anecdote that I want to tell you, that I actually generate these like images via generate an image in Google slide application. It's really cool. I really suggest it. Has some problems. If you see here in the middle, I got a few errors, quite a lot, but it's still really awesome. And so now let's start with the software quality. So what does it mean, software quality? The problem is that best practices and standards, etc., are very different. What happens if you have 10 or 1,000 repos, and each one of them might or a group of them might have different best practices? Okay, now a shameless plug. For example, with a tool like CodeEmerge, it's one of the leading tools at Codo that focuses on AI code review. It can automatically generate a best practice markdown for you per repo. The way it's done, it's analyzing last 12 months of PR discussions, and it's also learning from interaction. And that's like what I call pre-processing workflow. Before you even generate the code, before you're coming to the code review, there's a lot of work that is being done in a very rigorous way. It's not just like calling the LLM, hey, can you please go through my PR and build a best practice? It's like more rigorous workflow. And you can see my talk from previous AI Native DevCon about workflows, specifically how to build them, about Alpha Codium, etc. And for example, I wanted to use Codo, or you can use any other code generation tool. Here I'm talking about a code review tool by Codo, but you can use code generation tool to, for example, add some feature. And in this case, I wanted to add a favicon to a Chrome extension. I wrote it in the Jira. And interestingly, after I finished vibe coding this addition, I got an interesting suggestion, a code review suggestion by code merge, saying please do not link to the asset, to the image, rather add it to the package. For me, it was surprising. Usually I don't want to create big packages, like for example a Chrome extension, but because of one of the discussions we had in the past in this Chrome extension, saying that this Chrome extension is going for on-prem deployment, you don't want to link to assets outside the air gap solution. This was really exciting, and LLM could not do that without a pre-processing that happened in the past. And this is just an example of best practice that created that. And I know I ran quickly, but I want to cover more area, more ground. This is like 15 different workflows that you can get from code merge, and one of them is called scan repo discussions that creates that best practice mark. That was one example of a pre-processed workflow that you could do in order to increase code quality and put AI into work across the SDLC. And now let's talk about bringing context. So another feature, the same ticket actually, was around the same Chrome extension. It's basically a chat interface Chrome extension. The product team asked to add an autocomplete feature. Okay, an autocomplete feature where you do /, you get all the commands of one of our tools in a chat, doing a /, bring all the possible commands as autocomplete option. Now the thing is, the Chrome extension is a front-end repo, and the commands are a back-end repo. Okay, so what you can do, a pre-process workflow, okay, that you can call. Let's think of as let's say I'm like James Bond. Though let's call it, say, like RUG, multi-repo RUG. Okay, so like think about that pre-process as a concept. RUG is basically a pre-processed workflow that happens before you're using the AI to generate code, retrieval augmented generation, and then there's a workflow just in time while you're trying to generate code or test or review. Okay, and it's quite an intensive workflow. Here I simplify it into let's say 3 steps or 2-3 steps on each part. One, how do you turn a code base into a graph vector DB? And you need to have it in advanced workflow. For example, language specific analysis, class specific. If I have a file, like basically I have a Swagger file, or I have a C++ C header file, I want to treat them differently, hierarchical chunking, etc. And also when you're doing the retrieval, it's very different workflow to bring, and by the way, try it out. Try it on in one of your favorite tools. Try to ask, find a similar code, or find code using, or find code that does X. These are very different workflows that you need to have in order to properly do the retrieval process. So by the way, an anecdote, if one of you are thinking, hey, why not just push everything to like an LLM? Basically, there's a lot of papers are talking about it, how it would be useful to, even if you're pushing the context to an LLM, you want to order things in the right order, prioritize and organize. That's a workflow. How do you organize that? And also, believe me, you don't want to rely on the needle in the haystack. So basically, after you do this pre-processing, what you get is, when you're trying to vibe code this feature of autocomplete, if you do not use a RUG pre-process and post-process technique, then you will actually get a really good working features. You can try it in one of the leading code generation tools. But unfortunately, what's happening here is that all of these commands that you're seeing here on the top that we wanted to enable an autocomplete for are not real. Most of them are actually hallucinations. Okay, and if you do have a proper process of indexing your code base, etc., and that happens, let's say, every night or so, then you actually can bring the relevant like context to bring the relevant commands. Okay, and within one prompt, then you can get this result of a chat autocomplete, for example, as a Chrome extension on your GitHub. And to finalize, and then I'll stop and move to see like to do Q&A a bit, etc. I want to talk about like try to connect the dots. Basically, what I'm saying is that the world, roughly speaking, of software development divide into, let's try to define what we want to achieve. That's the spec. And then we want to implement it. And then we want to test it, verify, review, etc. And you can have like agent assistant helping you either complete chat, etc. But you can also have agents in workflows. I'm not trying to differentiate here between workflows and agent. I'll get back to that. To do pre-processing and enable you to have these agents grounded and working properly. That's the red team that I talked about. But also, you can have dedicated workflows that helping you transform from one to each other. Spec to test, spec to code. And these workflows could be very, very specific and detailed. And then when you're bringing the vibe coding and you provide these workflows to the LLM, etc., to the agent that is basically an LLM that calling tools, one of the things that could happen is that LLM is calling other workflows and agents that are more specific, more designated. And then finally, you get to that future where you're vibe coding, but with confidence. And what I'm trying to say here is that that super agent using a swarm of agent architecture that are more specific and based on workflows would enable you vibe coding with confidence, but also enable you a lot of workflows that are outside the IDE, that you would be able, for example, to do code review, code testing, code generation, RCA, root code analysis, and many other things that you're doing as part of software development that not necessarily happening in the IDE. And that's Gen 3.0. That's the moment that we're going to have like a full game changer. And it looks different for knobs and noobs, and enterprise. For example, for beginners, you might get all of this wrapped for you, and you get things like bold, lovable, etc. And for enterprise, you might get these as many building blocks that you want to play and adapt to your own requirement. So you can make sure that you customize it properly for your specific SDLC standards and code and software development standards. So that's it. I just want to encourage you to visit kodo.ai, obviously. And as mentioned in the beginning, I'm moving to New York, and we already opened an office there, and as well in Boston, and we are hiring quite aggressively. When you're dealing with like serving enterprise, we don't only believe in only on chatbots serving our clients. So we are hiring also humans. So please reach out. And with that, I'll be happy to answer anything. Okay. Oh, do you want to like? Did you read a Q&A? You want to offer like specific questions, Dion? Oh, I don't hear you. You're on mute.
Thank you. If folks have any questions, throw them in the chat. And wait for that. There was one that was about when you were talking about with existing projects, being able to create best practices and the like. Have you seen workflows as well to be able to point to like a golden repo or other repos in the company? How does that work?
Great question. So I do think that supposedly starting from greenfield is easier, and for example, vibe coding, etc., would work wonderfully as is. And I actually strongly hinted here that you can try to ground the vibe coding with information that exists in the past, and you're starting with a greenfield. So and that's maybe contradicting. By the way, I do want to say that for this time that I had, like I want to focus on one example of workflow, one example to create best practices. Okay, but there's many others, and I really encouraging like exploring. Now, back to the question. I think that there's two setups of greenfield. One, that you're starting a new project in an enterprise. You probably do have, from our experience, thousands, if not tens of thousands, if not more, of repos, even if you're starting a new project. And you want to make sure that when you're starting a new project, you're using APIs that already exist. You're using code that was already verified so many times in the past. And you want to either use that as is or be a part of the context and inspire you to do heavy duty, high quality code, even for the new project. Okay. So even if you're starting a new field, you can still, you still want to use that as context. For example, use existing code and APIs or learn from already achieved high quality code. Now, if you are starting a startup from scratch, I want to be frank with you, just move fast and break things. Okay. And I think like for that, I would actually recommend using the best practice, but you can even use the best practice given by tools that are building from you full website or few products from scratch. Start from there, start like doing that game changer products and do a POV, see if it works for you, etc. And as you go, start bring in your best practices and knowledge into your organization, and from there you evolve. By the way, notice that specifically, again, sorry for the shameless plug, we decided to use to have controllability and observability around best practice. We give you as like a file, like rules files. We could have trained a model, but then you don't see what's actually learned. So this best practice file, you can fill it with your specific information. You don't have to have Kodo merge asking it to review past PRs, discussions, or other repo, etc. You can write your own best practices from scratch. Okay, thank you. I think we're out of time. It was really.
I think we got a couple minutes if that's okay. To we got another other questions in here. So yeah, here we've got Min asking about where they can find out more about all the Gen 3 workflows that you talked about.
Oh my God, the reason that I actually was a bit in a hurry is because I'm going to a live conference, to talk exactly on Gen 3.0 like workflows. So first of all, it's maybe an opportunity to say that I try to talk about it quite a lot. So please follow me, Itamar at Mar at X, ITAMAR, Mar. And also, might do a webinar about it. I think you would, if you write software 3.0, for example, you will find interesting information on Google, Perplexity, or all the rest. I think you should also write agents versus workflows, okay? And learn about that. That's gives you a really good like overview of what the future holds, because I actually use these two terms interchanged between them, but they're but they actually complementary but different. Okay, so that's my three advice. Shameless plug. Follow me. The second, read about software 3.0 and read about workflows versus agents.
Sounds good. And then as we get into this world where there's a lot of extra context that's out there, you saw getting things from Jira, getting things from the docs. How have you seen people handle just like the skew of that information? Like code is kind of truth; it's always the running thing. How do we handle this massive other context that's out there?
Yeah, if I got you correctly, like basically, in addition to code, which could be massive or very little, very small, like you have Figma, the technical designs, specifications, for example, in Jira, and then like I'll do shameless plug to over Tessel for you guys. Like maybe you write your specs in Tessel, etc. and then you want to absorb that. So I think there are roughly two school of thoughts. One, just shove everything into a context window that is growing, and the other is use advanced RUG, and then an agentic, which is part of the tomorrow, an agentic RUG. Sorry, not RUG, RAG. Sorry, apologize for my accent. Agentic RAG would help you hop like on the huge context that exists and fetch the right one. We're very close to really advanced technology there, in like in Kodo, but other companies as well, I believe. And then like RUG is the future, in my opinion, not shoving everything into a context.
Yeah,
because of the problem of like a needle in the haystack and other things that I'm not sure that are going to be solved very soon.
Yeah, I was just there looking up the new RUG acronym. I was like, I've missed another one. There's a new, retrieval.
Yeah, I have a problem with this acronym.
No, it's all good. Well, Inmar,
thank you so much.
Thank you so much for sharing all of that. I'm excited to learn more about Gen 3 workflows, and look forward to chatting on Discord and chatting with you more in the future. Thank you.
Will do. Thank you so much for having me here. It's really wonderful ecosystem.
Cheers. Okay, so that was awesome. Really fun to hear from Inmar on those things. Next up, we're going to be talking about the age of risky software, which itself sounds excuse me, really fun. But we also have other things on the other stages too. So with Simon in the AI Today track, he'll be talking about use of fine tuning in both the world of completion and agents. So definitely consider that. And then we've got Josh Long chatting about all things Spring AI. So Spring's been really doing a lot in the Java world to be able to bring AI to the core framework. So check that out. And then in the second half, because these are 15 minutes, Rohit's talking about his Create MVP system that allows you to kind of bootstrap something new. But now in our world, we're going to get back to the world of tomorrow. And we're going to be talking about the fun things in the worlds of security. We got to see there was a big push with the DevOps movement where it kind of changed the whole world of security with just how we're changing how we're doing things on the ops side. Now with AI revolution, we've got LLMs that by their very nature are obviously very unpredictable. And so what's this all going to look like? Are there lots of opportunities for us to kind of still bring this technology to bear? What do we do in the kind of counter to be able to fix things? I can't wait to hear more about this. So Guy Po, who you heard in the keynote, of course, CEO and founder of Tessel, is going to chat with the CTO of SNCC, Danny Allen. Obviously Guy Po, you probably know, founded SNCC. So I'm sure they know each other really well, which is going to be great. And they're going to be chatting about wrestling with this new reality of security in the world of AI. So let's bring them to the stage. Okay, let's bring them all. Hey, how's it going, folks?
Hey, Dion, how are you?
Yeah, really good. Danny, how you doing?
It's great to be here, Dion. Kaipo, great to join you again.
Yeah, nice. Well, I'm gonna go off screen and let you guys chat and be watching for questions so we can do Q&A later on.
Sounds good. Thanks, Dion. Danny, thanks a lot for sort of coming in. I know we kind of barged in on a day of recordings. I think you've had a whole bunch of them today on it, so we'll test you out live here on it.
That works. I don't usually wear a sport coat, but just for you today, I wore a sport coat.
Yeah, you're doing it. Sort of wearing the formal wear is like I guess if anybody knows anything about me, is like definitely sort of in the SNCC's original culture, not so much a suit sort of environment on it, but I think as we sort of barged into like protect enterprise customers on it, it's like a little bit of a show me you're serious lens to it that was great. So let me kind of just introduce you a little bit. People have kind of heard too much about me on it, but just talk a little bit, Danny, about your background. Danny's, I've had the pleasure of knowing Danny. Oh, wow. I'm sort of, I think, a little bit embarrassed that now. It's like, I think it's not quite 20 years, but it's sort of starting to kind of push that envelope on it as we were building together some of the original AppSec products back in Sanctum Watchfire, and always sort of was always at the cutting edge of sort of understanding where we're building out. Ended up continuing to lead some research and security research at IBM after it acquired Watchfire, which we worked at together. And then through a bunch of sort of startup journeys, before Snyk was CTO at Veeam Software, talking also about sort of a different type of risk, right? Sort of managing backup software in big volume in the world of cloud, which was not always embracing. We'll touch on that in a little bit. Security as a first principle on it, and then lastly, we got the chance to draw you in to Snyk to come and be Snyk's CTO on it, which is very exciting. So like a long, amazing history that I've had the pleasure of sort of working with you in some parts of it, in the world of risk, of security of it, and today sort of dive in a lot into AI. So did I get any of that sort of wrong over there, Danny, on it? Any key pieces you want to add?
No, that's 100% it. I always like to remind people I started as a pen tester actually doing security testing, but I don't do very much of that anymore. It's been a fun journey, and actually working with you alongside you over the years has made it even better. So great to be here.
So I guess we're gonna go from kind of go through a little bit maybe the unpleasant topic of hey, you can just sort of vibe code your way and sort of have and not carry some consequences. We're gonna try not to be sort of too much sort of doom and gloom, because I think we're both believers in it. And maybe just before we cap in, I know you've been sort of delving into AI today. You're sort of with the security hat, but also developer hat in Snyk. Do you want to say just a couple of words about the type of AI work that's been happening that you've been immersed in before we get into the subject matter?
Well, I always start the conversation when people ask me about AI of what is AI, because I remember doing, cracking hash codes 20 years ago by chaining up a whole bunch of FPGAs. And so machine learning and we've evolved into where we are today. So I usually like to start with that AI. For myself, at least, when I use the term AI, I tend to think of generative AI, which is more relatively newer in nature. But as you might expect, we've been playing with all kinds of generative AI here on the Snyk side. Certainly the one that comes up the most is generating code, as I expect most of the audience here is using some kind of generative AI in the code world. Yeah,
very much so. I recently heard just like a bit of a snarky but still kind of true remark, which is if it works, we call it ML. If it doesn't work, we call it AI, which was just kind of a little bit funny. Like it's been around for a while.
Yes,
that's the new frontier. So I guess we're going to cover a little bit the security concerns of it, and I guess maybe just to tee that up as a question. So security is a real concern. AI is a very kind of volatile world on it. And generally the sense I get in conversations is that oftentimes security is a bit of a blocker or at least a very kind of source of anxiety when people are embracing AI. So I guess my question to you for starters is like, what are you seeing? Are you seeing security sort of truly blocking organizations and enterprises from embracing AI into the systems? Is it are they adopting it anyway, or is it actually slowing down? What are you seeing?
We're definitely seeing them adopt it. What I would say is unequivocally, people are moving forward with AI. If you ask me kind of in the enterprises, the customers of Snyk, it tends to be, certainly coding assistance. We see a lot of that, but you also see a lot of chatbots. You see a lot of support technologies. And I would say well over 80% of our customers are embracing AI within the organization. Now, if you ask me the second question of what is the biggest concern as they're doing that, it is security. But I would say it's not blocking things. It's more of a concern than a blocker in the adoption. In fact, adoption rates are extremely high, especially in the development community.
Yeah. And I'm curious, like, are you feeling, are the security people you talk to, they wish AI wasn't adopted, or are they also excited to sort of have AI adopted? They're just also afraid of the repercussions.
No, they're excited by it. The developers I talk to all want to use it. In fact, if the organization doesn't allow it, I would say chances are better than 50% for sure that they're using a Windsurf or a Codium or a Cursor or a Copilot or something within their environment. So they're definitely excited and energized by it. The one thing I would say is sometimes they, because this comment is now everyone's a developer, sometimes I think, well, really? Like, just because you know how to talk to a prompt, does that make you a developer? So there is, there's some cynicism there, but they're all adopting it. They're embracing it, is what I would say.
Right. Yeah. And I think, I guess one thing I've been excited to sort of see is that actually probably like many people within the security organizations are like highly technical, but not good coders. And in that sense, I see many of them actually kind of embracing small tools, the creation of small tools with AI for their own systems, not like the way they would identify attackers, but just sort of integration software or automation software of it, which I think is kind of fun. It's sort of to bring, if you think, harken back to the cloud, if I use that analogy, in cloud, I think there was probably more aversion, or my sense was there was more aversion by the security teams. They kind of preferred to not use it, and here it sort of feels like they're a little bit of a user as well, or an embracer. I don't know if you're sort of seeing that in the world of AppSec as well.
Yeah, I'd say that's definitely the case. And one of the areas is they're using it for curiosity. I unfortunately began my career, I guess, back in COBOL. And so if you ask me what I'm most familiar with, it's languages that are older today are considered older, C and C++ and COBOL and those, and Python, because I did a lot of security testing. But for example, I will freely admit I'm not very good at Golang. And so one of the ways I wanted to do something in Go was, so, I broke out a coding assistant and I said, hey, can you create this? And so what I'm seeing in the development community is they're using it to both augment skills in areas that they may not have skills, but they're using it to satiate the curiosity of how do I use this in my everyday life.
Yeah, cool. So I guess when people are assessing a security concern, again, I'm going to probably overdo the cloud analogy over here in this conversation, but when the cloud came about and it had a bunch of sort of security concerns around it, the solution was sometimes expected to come from the cloud itself, from the platform itself. And over time, I guess we've sort of seen platforms like Snyk, platforms like for sort of cloud native development, or like Wiz, or sort of others for sort of CSPM and such, actually be the solutions that layer on top of the cloud. So instead of it being built in, I guess, how many do you have a sense of how do people feel about, hey, the models will just become secure, or like these sort of code generations, they will kind of fix it on their own, versus a need for sort of dedicated security solutions sort of above the fold?
Well, AppSec people definitely believe that it's not going to secure itself, and developers generally are more optimistic and think that it will secure itself. And I think that both are true. The analogy to the beginning of Cloud Guy is actually super relevant, because if you think about when the cloud first started taking off, I mean, it was booming because people were saying, hey, I can get ROI, or I can get footprint in an area that I don't have. And if you fast forward after the inception of cloud 2 or 3 years, 3 big things were a result of that. One is we're still dealing with the security misconfigurations of storage, right? Open S3 buckets, like no one was doing anything about that. Then there was over-permissive IAM and access controls. And thirdly, there was very poor visibility and logging. And I would say that those same 3 concepts apply equally to AI. It's very much the same. And security people who are aware of this and know this say, this is the era that we're entering into. We're setting ourselves up for failure if we don't consider security going forward.
Right. Yeah. And they can anticipate that. And of course, some of the question is, well, what can you do about it? And I think, I guess another topic we've had in when we think indeed about sort of cloud and about application security is this notion of like transcending fragmentation, right? Of if you're using one model, maybe you have the aspiration that it will sort of secure itself, all those concerns. But when you're using kind of multiple models, do you kind of expect each of them to just sort of secure itself, or do you need something that's overarching? I guess when you're looking at enterprises today, are you seeing them generally like, pick a partner and kind of go all in with them, or you're sort of seeing a breadth of tool and kind of model adoption?
Definitely a breadth of model and tool adoption. Even I'll use our organization as an example. We have multiple coding assistants that are being used here, and we're using multimodal things. And we use, OpenAI for one thing. We use Claude 3.7 for another thing. And so that is what I would say is typical. And so if you want governance across all the different tools, across all the different models, then you need something that is outside of those environments. And while some models are better than others at securing things, I would say there are zero models that can secure everything. And so having some awareness of the types of weaknesses, I think, is a pretty important thing for most organizations to focus on.
So that's an excellent precisely to my next question, which is, let's sort of get a little bit more sort of technical. So like, what are the security concerns that people raise the most as you sort of engage with them? And especially when it comes to sort of AI development, right? And in this world.
Well, everyone starts with the OWASP LLM top 10. So you have model poisoning, data training poisoning, and prompt injection, and over permissive permissions, and all kinds of different vulnerabilities that people are alluding to. In the context of coding, I would say...
Maybe I'll just sort of pause you a second. Do you mind sort of saying a little bit about the OWASP top 10 and the OWASP LLM top 10? Sort of the developer audience doesn't necessarily, not everybody might know what those are.
Sure, yeah. So the Open Web Application Security Project has always had a top 10 of vulnerabilities. And in 2023, which 2 years ago was a lifetime ago, but it was 2 years ago, they published a top 10 vulnerability list for LLMs. The first one of those was prompt injection, and it went on from there to model poisoning and data theft and data exfiltration. And you can Google it and find what those top 10 are. I would say even in the 2 years since that came to pass, I would say those vulnerabilities tend to be out of date, because we're already facing new vulnerabilities. When you have an agent talking to an agent, there is no concept of the vulnerabilities associated with that. So it's evolving, and it's evolving very quickly, so much so that the standards bodies and organizations like OWASP it's hard to keep up with those vulnerabilities. Some of them, though, I would argue, Guy, are more real than others. In other words, I think some are overhyped, but some are more real, and they'll have longevity to them.
So let's dig into that. Maybe like a couple of examples of like which ones do you think? Maybe we'll start with the real ones, and then we'll sort of talk a little bit about the ones blown out of proportion. So like, which concerns do you find? Maybe like if you named your own sort of top three, that we have an audience here of developers or sort of building software. Like, which top three concerns them or their organization should really kind of focus on?
There are two that I personally worry about a lot in the long term. One is around identity and access management. And the reason I say that is because typically LLMs, the large language models, are trained with all kinds of data. And it's not true that everyone inside the organization should have access to all of that data. And so you hear this being used as jailbreaking the system or getting data that you're not supposed to have access to. That is exacerbated tenfold when you have agents talking to agents, which we're beginning to see now, where you have some agent using model context protocol to speak to another agent, and there's no concept of passing on authorization. There obviously authentication has been done, but authorization to the second model. So I worry about that a lot. In the concept of code, let me give you a specific example of this. If you have an LLM that has all of your internal code libraries, you may have code libraries for one group that you don't want exposed to another group. Well, how do you ensure that your secondary agent, your coding assistant, knows that I can access this library set, but not this library set? How do you pass that on? And so that's probably one of my top concerns, is around the data access. The second thing is the non-deterministic nature. As a security person, I'm always kind of very linear in thinking of, if I put in this particular, payload, I can exploit the system and get it to do something that I don't want it to do. By their very definition, AI and code generation of AI is non-deterministic. And so having an audit trail and being able to meet compliance requirements is actually really difficult in a world of AI.
Yeah, very interesting. Kind of the notion of attacks. I wonder if it's like a new pattern of attackers in which, like, if you don't like the weather, wait 5 minutes type element. It's like, hey, if this SQL injection didn't work, just try it again in 5 minutes on it. Maybe a new version of AI came along, and maybe that one is vulnerable.
And that manifests itself in different ways, because if you're doing red teaming, like if you're doing sequential prompt injection, you might do the exact same sequential prompt injection a second time and it works. And the first time it didn't, just simply because of the non-deterministic nature. So that could give you an inflated sense of confidence. And that's a problem in a deterministic security world.
Yeah, absolutely. Because you can't really attest to anything having kind of some longevity to it. And how, I guess, how are people dealing? So let's sort of focus on those two. I guess the first one is, I think, more of a constraint, right? I very much relate to like identity access and, or, you know, instead of me sort of narrowing it down, let's talk a little bit about those two cases and maybe what are some sort of mitigating controls, or what can someone do except for don't use AI, right? Or don't use LLMs.
Well, I never recommend that. I'm a big believer in embracing it. But on the authorization, authentication, mostly authorization, less authentication side, we're beginning to see it worked into some of the underlying frameworks. So you're beginning to see extensions of MCP, Model Context Protocol, to have authorization in there. And in fact, we're a member of the Consortium for Secure AI. And so you're beginning to see these frameworks. The A2A framework's another one. Google announced that at Google Next a month ago or so. Mm-hmm. And at the time didn't have any authorization in it, but already the working groups are coming together and saying, hey, let's introduce it. So my hope is, and Microsoft has embraced that. So now you have two giants both embracing the same concept. So my belief is that in the longer term, we'll start to work in authorization and identity and access management into the systems. The non-deterministic nature.
It's to an extent, it's like you wait for the industry standards to firm up. You participate in them if you are, like if you care enough and are able to do so. And I guess in the meantime, you sort of avoid topics that require them because they're just not satisfied quite yet.
Yeah, I would be very hesitant to do a lot around agent-to-agent communication or agentic to agentic systems because of that. Give it 6 months, give it a year, and I think we're okay. That's not to say don't embrace AI right now. I'd just be more cautious when you get into the meta layer of talking across systems.
Yeah, and I think that's okay. Like risk reward should always be kind of assessed on it. And I guess on the second problem of dynamic code and the code kind of constantly changing, first of all, like I think that probably relies, like it's especially true for agentic systems that might sort of change the code a bit more dramatically, shall we say. So before, let me kind of do a bit of a side tangent. We'll come back to this risk. Like I guess, how much do you see agentic kind of full on, Devin style sort of agentic systems being used in enterprises? Like, are they still in like, oh, this is really cool, I want to kind of try it out in the corner? Or are you sort of seeing any sort of real adoption on it on enterprise systems?
What I've seen, and this is the segment of the customers maybe that we're dealing with, what I've seen is this is cool, let me try it out on the corner. I kind of group them into three buckets, Guy. I have the highly agentic autonomous ones like Devin. You have kind of the medium ones like Augment that, can do a lot of things, but they're not fully autonomous. And then you have more of the assistant, the cursor copilot type style. I'd say very few customers within our customer base, at least, are going to the fully agentic. I would say most of them are actually in that lower autonomous model with the copilots and cursors, and maybe 20-ish%, 30-ish% are in kind of the middle that are doing very much more augmented code assistance.
Yeah. Okay, interesting. So I guess kind of coming back to the sort of dynamic nature of it, or sort of, like how do you deal with compliance, I guess? How do you kind of pass that? I guess what are there any kind of innovative approaches that you're sort of seeing? Like how are people dealing with that?
Well, a lot of logging and visibility. I said in the early days of the cloud that had these three problems, and the third one was that there wasn't a lot of logging and visibility. And the good news is people are logging it and actually getting interesting metrics out of it. I met with a large financial institution, a customer of ours, that said 11% of our code is AI generated. And I kind of scratched my head and I said, how do you get to 11%? But what they were doing was they were logging all the code that was being submitted into their source control management systems. And then they were logging all the code that was being generated, and they were doing some simple mathematics and division on that. So, whether that's accurate or not, for me, the positive outcome is that they were logging it. They were actually tracking it. And I think we'll see more of that as we go forward. Yeah,
makes sense. I guess maybe let's do some myth busting, of it. So I guess which security concern or two do you feel is you can theorize about it, but it's slightly blown out of proportion?
I tend to think the hallucinations is pretty blown out of proportion. I'm not saying it doesn't happen. I just think that over time we're going to see fewer hallucinations. And the reason why we'll see that is mostly because the models will test themselves before it returns output. And so I think hallucinations would be one of them. Identity and access management, I think, will get out of that problem over time. I think data theft is a very low, I'm not saying it's not real, it's definitely real, but if you ask me to rate it on a risk category, I think the likelihood of that being exploited is very low. And so, I always measure things on a risk scale as opposed to an actual security scale. And so while some of these things are real, I think they're lower risk than other areas.
Right. Yeah. And they might be sort of short-term risk. And I guess which when you think about fundamentals, like I guess you in general, when you think about sort of Gen AI and these tools, some flaws are just the baby steps, right? It's just immature yet. It's sort of evolving so rapidly, and some are maybe a bit more fundamental. I guess which security concern or two do you feel kind of have legs here, and they're going to sort of stay? They'll hurt us for a while, or that'll just be a concern that we really need to fundamentally sort of consider, because it's gonna be here.
I would go back to the same three things that I said about the cloud, and that's because we don't learn our lessons. In other words, I think that the configuration of AI is a problem and will continue to be a problem, generally around the permissive nature and what data it's trained on and all of that. The second thing being over permissive identity and access management to the data, where we're giving customers access to, let's say I'm training an LLM and I put all of my support data in there. Do I really want to do that if I'm giving customers access to it, because they could break out of their set of data? So I think that's the second one. And then the third one, I would go back to the visibility and logging. I think we're going to fall into the same trap that we did before, that we're not doing sufficient visibility and logging, and we end up in the same place we were with cloud after 2 or 3 years.
Yeah, of not knowing what is where and how is it happening. And I guess the other lens I think sometimes about some security concerns are due to the nature of the new technology, and others are they're just an amplification of patterns that we've already seen before, right? So like cloud accelerated development, or like DevOps accelerated, but like Agile came before that, and over time, like just sort of things moved at a faster and faster pace, and similarly, maybe like ease of creation improves, and as ease of creation improves, like responsible, like the level of scrutiny, or maybe the level of proficiency or professionalism involved in which of these things that goes. And that's true also like when I create images. Like I create images in a very non-professional way, and that's okay. I'm not going to like build any sort of a business around my kind of AI image creation. I guess do you think, does that distinction work for you? And if you had to choose, like which path you think is scarier? It sounds like you're sort of maybe leaning more towards the how we use it versus the tech, but I don't know if I'm
misrepresenting. Yeah. Well, I'm a big believer in that we should use it. Like I am not a slow down at all. We should use AI, embrace AI. I guess I always fundamentally go back to, we need to build in security from the very beginning. The problem that we've historically fallen into, every time we embrace a new infrastructure, doesn't matter whether it's cloud or servers or virtualization or AI, we forget the fundamentals, which are validate your input, encode your output, apply identity and access control management. Yeah. Like it's funny, while the threats or the attacks are somewhat different because the infrastructure is different, the root causes for them, Guy, it's been the same for 20 years. I mean, remember, right, Pop Shield, we were testing the input that was going to an application, right?
Yeah, a lot of the sort of the same fundamentals. I do find, for what it's worth, that I find myself almost more concerned about the explosion of usage than maybe even the fundamentals of it, which are much more sort of interesting. But so we've kind of seen how security hygiene is eventually the things that organizations actually get breached before.
What is different today than 20 years ago is there's far more data behind these systems. So the risk is greater if compromise occurs. 20 years ago, there wasn't the same amount of data. And now all of the data is behind there. And if the wrong person gets access to it, that can be very detrimental.
Excellent. So we have, time flies here. We sort of have 5 more minutes. I've got a few more questions to you, and then we have some time for Q&A. So I just wanted to remind everybody that you can post questions in the comments, and we'll have a few minutes for Q&A in a few minutes on it. I guess we're going to try and kind of go dystopian, utopian over here a little bit. So like we called this talk "The Age of Risky Software." Let's talk a little bit about like what is the concern here? What is the the path we need to beware, or is there even one? Right? Is it said to fall? Like, what do we mean by that?
The age of risky software, in the early inception days of a new technology change, is always the riskiest, because the pressure on the business, and I'm sure this is true of everyone in the audience, is use AI, be more productive, go fast, go fast, go fast. And so the early days are the greatest risk. And we are in the early days of AI. We don't understand it. I was listening to a podcast this weekend of, if you said Dave and Buster's in a voice message, the voice message never got delivered on an iPhone. It's still true, by the way, today. So we don't understand.
Like persona non grata type words that are mysteriously avoided.
And we don't understand how the AI is working sometimes. And so we're in this age of risky software because we're in this go fast, go fast, go fast, without truly understanding how it's working, how to secure it, doing all the right things. And so we're in the age of risky software.
Yeah, I think that makes sense. I do wonder, maybe coming back to sort of the overused sort of a cloud analogy we've been doing here, is when you think about the adoption of the cloud, the initial adoption was similar, like just as you're saying, like pressure to adopt, people used it, and it kind of, there was sort of this like world of possibilities. And we kind of went from a place, like we forget this, but like infrastructure used to be a fairly secure thing, like people like the servers and all of that, they were sort of run by a fairly small, very professional, typically very security aware group that was moving way too slow, which is the reason for the drive. And then cloud kind of opened it up, and suddenly people could do it faster, and more people could do it, and oftentimes without any really understanding of what it is that they're performing. And fast forward not that many years after, and until today, as you point out, like misconfigurations and sort of flaws in sort of infrastructure and cloud infrastructure typically are such a massive, maybe the top cause for breaches. And I guess I wonder, as we enable everyone to be a creator, to love, like in that notion to be a developer of sorts, of a type of developer, like a creator of software, alongside allowing existing developers to sort of run at like a much faster speed, maybe with a little bit less kind of scrutiny on it. Like, our vulnerabilities in code, the equivalent, are they going to be sort of our Achilles heel later? And I don't know, like, does that resonate? Is that a conversation, I guess, that and are we doomed to sort of just accept it if it is, because it is what it is, that tech will be adopted?
I'm an optimist. I believe in the long run this will sort itself out. But you've titled this "The Age of Risky Software," and I think that's why that is the case. Like, what we're doing is democratizing coding, clearly. And so we're going fast, and we're opening up the aperture, similar to what the cloud did, to more and more people. And so the result is more code, and more code means more vulnerabilities, right? Now, over time, I think we'll start to implement the controls and the guardrails to secure that. And I also don't, that's why you're still going to have developers. Just because more people can do development, that doesn't eliminate the need for developers. My son's actually in computer science, and he said, "Dad, should I be worried about, there not being a need for developers in the future?" And I say, that's ridiculous. Of course, there's going to need to be developers. What we're really doing is opening the aperture to more development. And when we do that, what we need are the security guardrails in place to ensure that we don't end up in a similar position that the cloud ended up in, right?
Right. Yep. Just try to anticipate. Hey, Danny, I'm going to switch to a bunch of questions. We actually, here, Dion kind of...
yes, indeed.
I think I learned sort of the operator system, and I found them, Dion over here.
Nice.
So maybe I'll just sort of lean in here and sort of ask Danny these. So Michael Wolf asks, you made a comment on passing authorization authentication around when agents talk to agents. That sounds parallel to passing around ownership and trading value for intellectual property or micropayments. Do you see security and ownership sort of in a similar lens? I guess this is to me more about like what are the sort of the assets and the validity of them that are moving around?
I see the problem as similar, but I see them as very distinct problems. The ownership of intellectual property and with AI is a real issue, and I don't want to minimize it. It's true for music, it's true for art, it's true for code, it's true for language and books and all of this. I can go tell AI to write me a book. Well, who should get paid on that? I'm not sure the answer to that. I think there is a secondary issue that is similar but a different problem that has to do with should they get access to that music, art, text, code,
right,
whatever it happens to be. So parallel but distinct. The reason why the micropayments is important is if we want the proliferation of AI to continue, then there needs to be some model of attribution, because otherwise you're going to lose all the people that are contributing data into the LLMs or the diffusion models that are behind AI.
Yeah. No, I think well said on it. And it's interesting to also think a little bit about the data assets that get moved around with protection on top of them. So that's also interesting. In that case, maybe they do blend a little bit more as almost like DRM style, like you pass along content with some security aspects to it. I guess another question is how will the role of attestation play out in terms of sort of AI agents and sort of a supply chain? Like when you think about creation with AI and such. Jason asked this. You have a view on how?
Here's one where I actually think the government, we're going to see compliance step in. And usually I'm not a big fan of regulation of new technologies because it's very difficult, especially for startups, to deal with it. But I think because of current compliance requirements, if you look at PCI DSS or any of these, regulations or compliance requirements, they require validation of certain things. And so that is going to require attestation of AI native software that is backed by LLMs. And I think this is going to solve itself. My only worry and concern, Guy, is that it becomes very fragmented. What you don't want is a GDPR for every country in the world or every state in the United States. And that's a bad position to be in. So hopefully we consolidate around some very common, well thought out requirements or regulations around attestation.
Yeah, that makes sense. But it also makes sense kind of at the meta level, which is AI will be unpredictable, but there's no reason for it not to be traceable. You might not know, what will happen, but you want to do that. I think I've got two more questions. I think we really kind of have time for one. So one was about the scope of AI security. I'm going to pass on that. Sorry about that. I think it's sort of too big for the time that we have to capture here. I'll ask maybe something a bit more concrete, which is which security checks can developers currently build into their agents to try and mitigate as many risks as possible? Kind of ending on a very practical bit of advice.
Yeah, well, I would say two things. One is if you're using open source components, and actually one of the things that worries me about AI coding assistance, by the way, is that it replaces to some extent open source components and tries to custom create them, because what's the downstream patching and updating of all those open source components? That's a problem. But I would say two things. One is validate the packages that you're pulling in for validation, and then code that you're writing. It's very easy. You can use AI actually to test the data flow across that code and to generate a fix for it. And so if you ask me very practically, what I think you should do is validate your open source packages. And if you're writing custom code, validate that the flow of that code isn't breaking the build in other areas.
Yeah. I love that. And I guess, the more you automate that, the faster you can run, right? And people kind of forget that putting guardrails, it sounds like a cumbersome thing, but actually when you put the guardrails in, when you're sort of running on a bridge with rails, you can run faster because you're not afraid to fall. And so we want to put those in. Time flies. We're sort of here we are, sort of 35 minutes sort of later on it. Danny, huge thanks again for coming in and sharing this knowledge and for I guess investing in AI security.
Well, thank you for having me, Guy. It's a great conversation.
Very cool. And Dion, I think we are ready for our sort of next session. I don't know if you want to sort of sneak in one sort of final question for us.
Yes, I know there are a few more that were in there. I'm really curious about just developer trust. As developers use all of these tools, how do they get a feel for what they can and cannot trust? It seems like there's a lot of perception and feel, which is interesting.
It's
cool.
That's a philosophical
Sounds good.
right there.
Yeah, cool. Thanks so much for the chat, and really appreciate it. We're going to move on to the next one. Thank you, Danny. Thank you, Guy. Awesome. Okie doke. Well, we are, put this up here so you can see, we are 2 down in the AI Tomorrow track. We're going to be moving on to a really fun chat with Ray Myers in a second. But just to make sure that you're aware of everything that's going on the AI Today track, we're going to be moving to Drew Knox, someone who's a PM on our team. Worked with him obviously here at Tessel, but also at Google. We worked on Chrome together and the like. He's been just doing some really interesting work as it kind of ties together our AI team and the world of evals. And so if you're interested in that whole world, go check that out for very kind of practical today advice. And then in the in action world, we've got Indu talking about leveraging AI agents for adaptive real-time API optimizations. Really curious about that, especially like on the fly UI refresh in production. I want to understand what that means. So that sounds fun. And then Andrew talking about AI-driven load test analysis. So how do we use AI in different worlds like load testing and the like? So lots of fun practical tools to play with there. But let's move into back to our world again and get back into the world of tomorrow. And I was really interested just looking at the initial abstract when it came across of just like, I think there's something that a lot of developers are feeling, which is like, how is the developer's role going to evolve? And then there's, sometimes the fear of, is it going to vanish entirely? Danny just then was talking about like, no, there's lots of room for developers to actually grow. And all we're really going to get is the ability to program absolutely everything in the world. So there'll still be a need for human developers to do a bunch of things. But which way are we going to go? Are we going to head to utopia or dystopia? Right? Are we going to get the innovator's paradise or the infinite pile of garbage? Are we going to be stuck just reviewing millions of PRs and the AI gets to actually do the fun stuff when we've been told that the whole point of this thing is to kind of reduce toil? I think there's just lots of questions that are on all of our minds, and Ray Myers is going to share wisdom on this very topic. He's a very tenured engineer. If you look at his history, he's been doing this a long time. I won't embarrass him at how many years he put in took into this, and he's really enjoying exploring just kind of this intersection of AI and maintainability beyond his engineering craft and prowess. He co-hosts the Empathy and Tech podcasts. He publishes content on the Craft versus Craft YouTube channel. And so, he's always kind of not just thinking about these things, but sharing and discussing it with us. So let's welcome Ray to the stage.
Thank you very much.
How's it going, Ray? Nice to meet you.
Very well.
Thanks for taking the time to chat with us about this stuff. I'm really excited to hear what side of these different paths you're going to lead us down, and then maybe we'll make some decisions on where we think which path that we're going to go down.
Absolutely. I mean, that's what I want to do, is just get us having better conversations more than today. While I do have a point of view, it's really more about how do we approach the chaotic diversity of points of view in this space. And as you mentioned, I'm currently chief architect at All Hands AI. We have a coding agent called Open Hands, which actually this week was just shot back to the top of the SWE-bench verified leaderboard and is the only open source agent in the top 10. But I'm here today to talk about something different. And as I was putting this together, I realized this is not even an AI talk. And this is perhaps not really a programming talk either. This is a talk about empathy, and this is a talk about listening to each other. But if that sounds uncomfortable, then don't worry, because we will have AI and programming in the, as a backdrop, a nice, comfy backdrop for these concepts. And let's start a little bit with where I felt I was coming from. This is a day in the life of an AI skeptic. Someone will say something very provocative publicly, like recently you might have seen the Anthropic CEO's remarks on, many different topics, many different professions. One quote that we saw a lot was, in 12 months, we may be in a world where AI is writing essentially all the code. I think we've got 10 months remaining on the clock there. So when we hear things like this, we have questions. I would definitely encourage you to check out Cal Forcer's talk on this track as well about, the other 70% of engineering, because those of us who have, been in the field are aware that just writing essentially all the code isn't the entirety of the job. There's a lot of different room for interpretation here, but regardless, we hear things like this, we have questions. I posed a particular kind of playful challenge about, okay, if we can do all the code, can we kill one mainframe? Can we replace the code in just a single mainframe? Half of the US GDP is still tied up in companies that use mainframes in some capacity. Really, the specifics of my challenge are not really important. Just for the last 2 years, what I have been repeatedly saying is that language models break old code. I've been saying that in every way I know how and testing that assumption and trying to find ways around it. I see this as the central problem we have to tackle bringing AI into software development, is that code needs to continue to develop as a synonym for change. We can't just be thinking about, can we make some new prototype? What are we going to do with something that already exists? And when I bring up what I see are pretty basic facts and questions in that regard, all sorts of things are hurled at me. I am called a Luddite. I'm told I have my head in the sand. I'm told I'm missing the big picture. And at this point, I literally work on coding agents full time. So if I'm a Luddite, I don't know what you want from us, but and in particular, in response to the last post, mostly positive feedback, but one person, the full quote was, missing the big picture so badly that it physically hurts them to read my post. It doesn't feel great to be talked to in this way. You perhaps have also seen this one, maybe many hundreds of times, the phrase, you'll be left behind if you don't, subscribe to their newsletter or use their preferred type of tool or whatever it might be. You're going to be left behind. I mean, this is language that is better suited for an apocalyptic religious prophecy in the form of a B-movie series featuring Kirk Cameron than some kind of nuanced technical discussion. I don't like telling people they're going to be left behind. I also saw this phrase said with more or less a straight face, resistance is futile, said by someone with some really respectable accomplishments, someone whose work that I admire and might even be one of the speakers at this event. I'm not sure. I don't know what to do with this when I see things like this. I mean, for all the money in the bank, you might recall who said resistance is futile. Who is being quoted here? Was it said by the heroes of that story? I mean, no, it was said by the Borg, one of the most notorious villains in the history of science fiction. If we find ourselves quoting them in earnest, are we really on the right side? Jean-Luc Picard would never say resistance is futile. He only said that as Locutus when the AI was controlling his brain. And in the story, resistance wasn't futile at all. They did resist and they were successful. Jean-Luc Picard would say, if you are on the side of truth, resist to the last breath. But okay, we need to breathe. I need to slow down. I'm just responding to emotionally charged rhetoric with other emotionally charged rhetoric. And before I know it, it's 9 a.m. and I'm already worked up on LinkedIn. I chose to become involved in this dialogue. I believed that I had some insight as a legacy code expert. And if I'm going to make any headway in that dialogue, I need to be able to engage with people who think about things somewhat differently than I do. They also believe they're in the right. They also mean well. They have a different view based on their own reflection of the answers to certain questions, and they're maybe trying to warn against some things as well. So what are we even talking about? It all hinges on, just sort of different answers we've come up with to this fundamental question that's all brought us here together to have these awesome discussions, which is what is the future of software in light of the AI changes recently, in light of a lot of other pieces on the board. So in service of that dialogue, I have found that it's really helpful to just lay out what the viewpoints are that we see people clustering around. And then we can identify, okay, well, you're in that camp over here. That's why you're saying things that are so different to what I think here. And we can start to untangle things. So I'm going to name these scenarios first, and then we'll get into all of them. And perhaps you'll have different names for some of these, but I'm calling them these. 1 is extreme completion. 2 is the devocalypse. 3 is abstraction leap. 4 is uncharted waters. 5 is the review economy. 6 is the infinite pile of garbage. So perhaps the most conservative, uncontroversial outcome here is the extreme completion, because it has already happened to a fairly significant degree. This is things like your coding assistants that appear in IDEs and editors. And more recently, you've had the coding agents, which have a little more autonomy, but basically is bound to completing your immediate thought on a tactical level. And they're operated by programmers. The AI does the typing, but ultimately, if this is all that happens, our job doesn't fundamentally change. You still need a great deal of coding expertise to use these in a sustainable way on an existing code base. A great convenience, but ultimately not a game changer to the degree that many people think we can achieve. This is an example of it. This is the cursor editor. It's quite popular. And here I am doing some autocomplete action on some Haskell code where I've got one function that already exists, and I would like to make another one, clean prime prime, that will remove both leading and trailing spaces. Sure enough, with the help of Claude Sonnet, it plops that out. It is perfectly serviceable code, but I'm, making a suggestion at a pretty small micro level in order to do that. The reason, by the way, that I'm using an example in the programming language Haskell is because it has very advanced type checking. And I think type theory is a very rich area to provide checks that form kind of a counterbalance against the non-deterministic nature of language model output. So that's food for thought. But then we have more agentic examples, and there are a number of these. The one I happen to work on is OpenHands, and this is something I did just yesterday, where we do this with just routine tasks, and this is just a new way of interacting with it. It's a Slack chat integration that's experimental, and I said, hey, we recently had to update this log statement in this particular way. There are probably others in the code base that need to be updated in that same way. Can you go make a PR that does that? Comes back a few minutes later with a whole 48 file pull request for me to look at. That's even going to the extent of like, it wrote scripts on its own to help it find the cases it needed to change. Very interesting stuff. I mean, this is nuts if you just showed this to me a couple of years ago. And albeit it's a small kind of tactical request, but even to be able to have this kind of all-purpose tech debt dirt shoveler, really cool. And there are multiple agents that can take on in a code base of this size, about 100,000 lines, tasks even more sophisticated than this. This is fairly low ball for what it could do. Again, that's all though in the extreme completion camp. I argue that would not fundamentally change the world of software development, it would be a great convenience and is worth doing. A more extreme point of view is the devocalypse. Now, when some of us get in these contentious arguments, I think it is often on one side or the other are believers in the devocalypse, the developer apocalypse. So there is no longer anything really even resembling the role of a software engineer as we see it today, or it's highly specialized, very few of them. However, it's not an apocalypse to everyone. This is also important to understand. To many people in the pipeline, it is the innovator's paradise, right? Our elimination is their empowerment, perhaps in their eyes, right? Like if they are a product manager, if they are an entrepreneur, and they can go directly from having an idea and designing it to using it and selling it to people, that seems very great, right? We, of course, feel like, hey, why wouldn't anyone? Doesn't everyone want to work with us? Well, I mean, I don't know. Sometimes we're very expensive and cranky. So this contention of like who wants what in the conversation also is an impasse to us understanding each other, because we can say, look, it's not going to be able to replace all of the work because you just don't understand all the things we do. There are scale and sustainability concerns and so on. And they will think you're just saying that because you want to keep your job. Well, okay, I do want my friends to keep their job, but I don't think that's the only reason we're saying what we're saying. I think there is legitimately subtlety to managing complex piles of software and a lot of unanswered questions in how machines could let people without certain skills take over that. But to argue for the devocalypse, we have to know how it would actually be brought about. So this brings us to the next scenario, which is abstraction leap. This is essentially the notion that in the same sense that we used to write assembly language, and now we write in higher level languages, that there will be another leap of a similar magnitude, such that what we now think of as source code will be somewhat of an inconvenient detail to most of the people most of the time. It would be almost as specialized as diving into LLVM bytecode or assembly or something like that. That's very interesting. How would that occur? Many people believe that we're already seeing it. It's prompts. Prompts are the new source code. LLMs are the new compilers, some say, and that's how standard source code's now like assembly languageable. Natural language becomes the artifact we maintain. Somehow it is structured somehow and tested. And the objection to this is usually, and I fall into this camp, that this is just not predictable enough to scale, that it works on small or low stakes situations, but it's not really something you can build on. Language models do not constitute an abstraction, because an abstraction needs to be robust enough that you can not be constantly pulled back into implementation details. People do have other points of view. They believe that we'll be able to solve that problem. It's unclear to me how, but it's not impossible. Here is an example that seemed pretty promising from back in 2022. This is some source code from a paper called Parcel. If you go there and look up this source code, you can see 61 lines of structured prompts that have turned into an entire Lisp interpreter and about 200 lines of Python. And as you can see, in these functions are not being defined with any source code, just the description of what they do and an example of input and output. And then you see parse has a utility function that's being, kind of indented under it. And there's many levels of these indentations. That's very interesting to me, actually. It does seem like it's a legitimate attempt to make this prompts as code thing more robust, more scalable. Will we be able to actually productize this? There are a number of attempts. We'll see where that goes. I think a more plausible way we could achieve abstraction leap is with DSLs, or domain-specific languages. Now, if you're not familiar with DSLs, you probably already are familiar with them. If you've used developer-facing ones, such as SQL, such as regular expressions, and most office workers, to some degree, use the world's most popular DSL, which is Microsoft Excel, right? The spreadsheet is also a form of DSL. And there are many more specialized ones to particular business domains. So what this is an upfront investment in making a very specialized programming environment that makes expressing certain kinds of thoughts very efficient. And this empowers domain experts. This has kind of interesting cost trade-offs that has improved over the last 20 years with the advent of things like language workbenches, they're called, which are specialized tools for making programming environments of this kind. And there's also, like, some call it a paradigm called language-oriented programming. These are some tools that are in that space. It's easy to imagine that language models, and there's been some work on this already, will both speed up the process of making these DSLs and also provide this automated completion for the people who are using it. This is a video on the right by me from my YouTube channel, Craft vs. Cruft, talking about why I kind of dedicated 2025 to studying DSLs on that channel. And this from on the left is a talk called Empowerment of Subject Matter Experts by Marcus Volter. And he is one of the big experts in that space, done a lot of different custom DSL implementations. So these are areas that are pretty interesting to look at now, I think. But what doesn't, that's an example with abstraction leap. It's still code under the hood, ultimately. We're still in uncharted waters there. The next scenario is uncharted waters. Many people believe that AI will create a future of coding that is not even code-like, actually. It's a future of computing, perhaps even without code. What does that even mean? I'm still kind of struggling with it. Some people believe that model inference, just the neural network as the execution engine instead of the CPU, will become a more prevalent model of computation. Then you have the idea maybe AI will get so sophisticated that it's inventing new programming paradigms, and we can't even conceive of it. I hear a lot of these ideas, and I guess it's just hard for me to run away with it without having a more concrete notion of what it will look like and to be able to prove it at scale. So I think it's prevalent enough. We must acknowledge this point of view that the future is going to be something that's just not at all like the past. I have trouble being asked to prepare for it if we can't establish it more concretely than that. So moving back down to earth is a concept I call a review economy, which is already happening to some degree. As we are able to create more and more coding suggestions, we are now limited by our ability to validate them, right? We have agents, we have Copilot assistants pushing these suggested changes of kind of questionable validity, but lots of speed at us. And we are, in the extreme version, our job is just reduced to checking and reviewing this machine output. That's kind of a dismal future to many people. I don't think we necessarily want this. I also don't see it as an end game so much as a pit stop. I think if we wind up with anything that looks like this, we have just failed to manage our bottlenecks well. We need to be going further to the left here and figure out, okay, how can we get the system to be giving us suggestions that are right more of the time, such that we're not constrained in this way? Or maybe we need to prioritize them to be looking at the most valuable first. A pro tip here is, if you're not familiar with the body of knowledge theory of constraints, anytime your life looks like this with a big choke point, the thinking processes introduced in theory of constraints are very helpful for analyzing the situation. So finally, we have the most dismal scenario, the infinite pile of garbage, which is where AI has made it very efficient to create code of dubious quality to the point where our products get worse and worse over time instead of better. And we are ultimately just sort of crushed by this mountain of tech debt that not even the AI can help us build or dig our way back out of. There's some support for the notion that we might be heading there. For example, this is a white paper by UpLevel where they have done some controlled experiment where they've given some subsection of developers access to Copilot and seen they had a much higher bug rate and their progress through issues was relatively consistent. I mean, that would be a terrible outcome, right? Is if even the perceived productivity gain weren't there, but quality plummeted. Hopefully that's not the case, right? But that was what they saw. GitClear also has a white paper, and they did more of a metrics approach here. And in analyzing code historically, they found that 2024 in their records was the first year that there was more copy and pasted equivalent code than there was moved code. That's kind of scary if you've seen what the results of that can be. Again, there can be rebuttals that like AI coding assistants simply change the dynamic of what we should expect. Maybe the duplication's no longer so unmaintainable. I think that would need to be established for us to say it confidently. Right now, I think we just need to get to the bottom of this and figure out, does it need to continue to happen? But these are just a couple of white papers from a couple of maybe self-interested parties. Not everyone thinks that. Unsurprisingly, GitHub does not believe that GitHub Copilot decreases quality. They think it increases it. And they have this blog where they've also done an experiment, not this time on work on production code. The things, their rating of the quality improved by using Copilot. Obviously, they and maybe the others too are self-interested observers. Maybe even so am I. We need to figure out what's going on, is my takeaway here. I want to be able to come back and be citing actual papers and not just white papers, and hopefully like a meta-analysis of good research papers. If you know of some work in the space, I would love to get in touch with you. In the meantime, I think we're better off studying just past work on developer productivity than to think that we get to and code quality, to think we need to rewrite all of the rules with AI and start from no knowledge at all. People will look at these and say, okay, it's maybe producing dubious quality or more bugs now, but it will get better. I say we will need to make it better in order for it to be better. The models will have more capabilities, but we need to use them very judiciously. We need to engage in careful design. So getting to the end here, once again, the scenarios that I've identified, you might see others or want to call them different things, are extreme completion, devocalypse, also known as innovator's paradise, abstraction leap, uncharted waters, the review economy, an infinite pile of garbage. We won't just go to one of these places. We'll probably go to several in different ways. They interact, right? So, for instance, many people believe that extreme completion will become this sort of vibe coding revolution where it leads to the devocalypse. And others are worried that we will miss that outcome and it will drive us into infinite pile of garbage. I have expressed, like, if any of these are going to completely transform programming, it might be carefully designed abstractions in the abstraction leap scenario combined with our completion capabilities. But again, there will be multiple things that happen and they will affect different sectors of the industry differently. So someone might have a very different point of view than you and still be right within the area that they're thinking of. And we get a say in what the outcome is going to be. I don't want us to sit here and feel as though we're just waiting for a meteor to hit us. Developers are kind of uniquely positioned to be engineering our own future rather than waiting for it. So I think we need to get a clear vision of what our goals are. What do we want from software in the world? Do we want more developers? Do we want fewer? Do we want software to be of high quality, or do we just need more of it no matter what quality it is? What are we really demanding from the system? I want many things from software. I want it to work well. I want it to be valuable to its users and to the people who are building it. And I want people who work together to treat each other well. Well, thank you very much. I look forward to your questions.
Okay. Hey, how's it going? Thank you so much, Ray. I've got to say that was incredibly enjoyable. It was just really fun, just hearing you go through, all of those things, and it's definitely got me thinking about what I want. Like, I personally love the democratization of software, and so that's one of the reasons that I'm excited about a pathway we can work out to take AI to actually help with that. Like, a lot of my career has been in the world of the web. Like, I worked on Chrome and the like, and it was exciting to try and get as many people as possible actually doing development. But really interesting to think through these things. So, okay, let's get to, we don't have a lot of time, so let's jump in with a question here from David. What do you think is the single most impactful thing we can do to reach the best eventual outcome and avoid the worst?
Yeah, well, I'll tell you what I spent a lot of last year doing is I briefly abandoned AI and studied formal methods for the year. I went and learned theorem provers. And then I went and worked for an AI coding agent company only after going on that side quest, right? So basically, if I was to generalize that into advice, I mean, do learn theorem provers if you have the stomach for it. Really intriguing stuff. But just let's not pretend the rest of computer science doesn't exist and the rest of human understanding does not exist. Let's not use this as an excuse to not study what we already know. A lot of the problems, a lot of the gaps that LLMs leave are filled by other areas of understanding if we just let that happen. And we don't look for all of the answers within, whatever the newest brand of AI is.
Yeah, that makes sense. Awesome. Oops. So one question I had is you mentioned at the beginning, and you've sprinkled in a couple of times, that you work for Open Hands, but folks may not actually know what that is and the history. I think it was Open Devon back in the day. Like, I'd love for you to just share a little bit about what Open Hands is and what you're up to there.
Yeah, and we're in this area where back in the day is a year ago. That's what we referred to as back in the day is amazing. Like earlier I said, back in 2022, like it was the dark ages. So yes, Cognition Labs announced Devon, a proprietary tool, in, I think it was March or April of last year. And they announced it as the world's first AI software engineer, a term many of us deeply disagree with. And then, however, we were very intrigued by the kind of value proposition they had of this thing that autonomously carries out your tasks. We'd been using these things where we're kind of copying and pasting broken stuff into chat. And we recognize if we can just have the LLM fight through these errors, it'll be much better. We know we can do better. So the product direction was super influential. And it kind of became this rallying cry of let's create an open source one of those. And several groups, including the people that made Sweebench at Princeton, and then this group that came together with Open Hands. That was originally Open Devon. The like, can the open source community produce one of these that's competitive, that is achieving the same scores? And it did in very short order. And that ultimately became a company. And I went from cheering them on to joining them.
Nice. So a lot of the AI companies talk about, how much of the code of their product is written by their product and the like how can you share anything of how you use Open Hands to build Open Hands and how that's gone and the pros and cons and all those things?
Yeah. That could be its own interview just on that topic. But briefly, like some of our recent blog posts, if you go to all-hands.dev, actually do discuss that Open Hands is, by the numbers, the biggest contributor to its own code base currently, albeit there's always, a developer who's prompting it. But some of them are kind of fire and forget pull requests. Like we just tag it in an issue, it comes back with something. We might tag it a few more times with things we want to change. But that's like kind of the best case scenario, is when the task is carved out enough that we can do that. I also use it for investigations a lot, though. Like, can you, poke around? I'm getting this error. Can you poke around and give me some ideas about why that might be happening? So there are more interactive flows as well, but it's for things that are like in editor work, we're still using, tools like Cursor, because we have kind of intentionally chosen to operate in the outer loop, the more autonomous workflows. We're not trying to be the best, development environment for coding interactively.
Got it. What about the role of tests? Sometimes I've found myself where folks have come and been like, hey, my developers don't like writing tests. So if your tool could write a lot of tests, that'd be really great. And then wait, if we have all these tests, then we can have a great, it's like, well, there's a bit of a chicken and egg there too. If the AI is writing both of these, what's your experience been around, the role of tests with AI?
So I come from a background, like my first job, I did the extreme programming methodology for 7 years. Test-driven development, pair programming, and everything. So I have a lot of thoughts on testing, right? I do value it heavily. I love that coding agents can help me write tests. I don't love that they don't do it unless I ask them to. I think that is in this whole space. I'm calling us all out, not any particular players. It's not going to have good results that our tools by default, when they you ask them for something, are currently most of them giving, okay, here's some untested code. The systemic result of that will be that people are writing less tests. I do love that when you choose to do the right thing, it will help you. There's also traps you can fall into of am I not writing the tests that are going to give me the best outcome? Am I just getting code coverage for its own sake? But that was kind of always here with tests. So a good convenience.
I found with the fix loop, it could be fascinating when I feel like it's easy for developers to just grab a stack trace, from a failed test, say, throw it in to AI and just say, fix this. And it doesn't have the right system prompt around it for fixing or whatever. And then it'll come in. There was just one recently where that kind of fix was all about localization, and it would create a solution just for the Turkish language for this particular letter, and then the test pass. I mean, we're back to 100% test passing, right? Rather than actually understanding the core problem and fixing the whole core problem, right? And when go in there, you can do you see those kind of things as well, where it lots of feel good, lots of green, but not necessarily getting the level of quality?
Yeah, I mean, we see more extreme things than that. I've seen a variety of these tools. Again, this is the coding agents in general are known to pass tests by deleting entire areas of functionality. The thing you're asking me to execute successfully would work if I just deleted all this stuff, right? And that's not common, but it's not unheard of either. If you've been around the block with these, you've probably seen that happen. Yeah. That's scary, but it's, again, it's only scary depending on how you manage your process. Are you going, if you catch that in review, incredibly easy. It's the subtle bugs that I'm more worried about, but it does, it gives you an impression of the kind of leash we need to have these on right now.
That makes sense. Okay, we got time for one more question from the crowd here. Radhika is saying, do you think relying on GitHub Copilot too much might make developers too dependent on AI, or does it just free up time to focus on more complex problems?
Yes. So you've heard these kinds of arguments come up with just a variety of conveniences that have happened over the years. And the criticism is right in some ways, and it misses the point in others. But I would say that pedagogy, the study of how we learn, is more complex than are we doing something that's hard or not. You do need to do things that are challenging in order to really learn about what's going on. But just looking for the things that are the most mundane pain in your rear end doesn't by itself mean you're learning the most. We need to treat learning as its first class, as a first class thing that it is.
Awesome. Ray, thank you so much. That was really thought-provoking and interesting, and really appreciate you taking the time to share that with us.
Thanks for having me.
Yeah, cheers. Okay, folks, we're coming up to our halfway point, so we have a break now. So, can take some time for a bio break and the like, and then we have a fun activity happening, some cool vibe coding that you should check out over in the Today stream. So please stretch your legs, go over and check out the Today stream and see what's going on, and then I'll see you after that back in the next half of the sessions. Thank you. Hello, welcome back. Hope you enjoyed getting a bit of a stretch of the legs or watching the vibe coding. That was really fun to see. Watching Petra become a developer. We're going to have to get her to solve a few PRs over here at Tessel coming soon. That'll be fun. So now we're in the second half of our track, and we're really excited to get the next three items going. And so we're going to be going through here just to show you, just so you can see what's going on. We've got, we just had the fun talk from Ray, and now we've got George coming up. And then you can go over to the other tracks to see what's going on. But let's get right to ours first. The title of this, Reliable DevOps Agents for a Self-Driving Infrastructure, like every part of it kind of sticks out, right? Like, what is self-driving infrastructure? And having reliable and agents, like, how are they reliable yet? Really excited to see what this talk is all about and learn from George. George is the founder and CEO of StackPack, and he's going to talk through all of these learnings from building and evaluating DevOps agents. So let's welcome George to the stage.
Hello.
Hey, how's it going? Welcome.
Hey, thanks for having me, Dion.
Of course.
It's a pleasure being here.
Where are you coming from, actually?
Yeah, I'm dialing in from Egypt, Cairo.
Oh, nice. Well, thanks so much. That's a little bit later than here, even. So thanks for staying up late for this.
Thanks. I'm really excited.
Yeah, awesome. Well, I'm gonna get off the stage myself and hand it over for you and get your slides up, and then we can get going and go from there. So have a great chat.
Great, thanks, Dion. So, reliable DevOps agents for self-driving infrastructure. So let me tell you a bit about myself. So I was a founding engineer at a couple of other startups, always building infrastructure and doing like the security work. So I've been writing code for 10 years now. I really like doing calisthenics, like bodyweight exercises, riding cruisers, and like volunteering, teaching people like how to code and how to do infrastructure. I really like developer experience and security, which are usually two things that never mix well. That's what I'm mostly interested in. So let me tell you a bit first about the problem. Like, why is this necessary? Like, why do we need the self-driving infrastructure in the first place? So today we've been interviewing engineers, like developers, software engineers, and engineering leaders, like hundreds of them every year since we started StackPack. Because, like, as you guessed it, like, we're working on trying to make infrastructure self-driving with like reliable configurations and agents, which are things like that don't mix like security and developer experience. So like agents and reliability. Like, how do you explain it? So here, like, I grouped a lot of the feedback we got from different people into like fictitious three personas. So DevOps engineers see that developers have no clue what they're doing. So they don't know a lot of things about the system internals of all the DevOps tools, of all the complex infrastructure they deploy their apps on. At the same time, platform engineers are sick of spending the majority of their time on support tickets instead of doing platform work that optimizes costs or like makes the developer's life much easier. On the other side, developers, like, they see a huge mismatch or like misalignment in priorities. So developers want to get this bucket or like get this feature out. They want this to work, while DevOps or like the infrastructure or platform team want to move to Kubernetes. So like there's a lot of misaligned like priorities and a lot of like bottlenecks in the infrastructure. And this pain keeps growing even with internal developer platforms and the abstractions people are building to make this thing easier. And the reason this is so tough is because there are like hundreds of DSLs, like a different configuration parameters and languages and schemas that you need to learn to figure this out. So we call this DSL hell, like domain specific language hell. It's not just the DSLs, but also the schemas themselves configuring. So like YAML is sort of like a data language or DSL, but then there's like hundreds of ways of writing YAML to configure all these tools. So you're not just writing a programming language and building stuff, but you're configuring other tools, and these tools have internal top secret information about how they operate, and you need to be aware of that to be able to write these tools. So it's like a very minority, like the minority of developers understand these tools really well and understand all the different combinations. And I've rarely seen a DevOps engineer or infrastructure person understands all of them, but like always a subset. So that's one reason why this is very difficult. There are a lot of things to learn and you have to keep in your mind to be able to do this kind of work. Another thing is that most of the abstractions in this, like we have layers of abstractions in infrastructure, and almost all of them are leaky. So for example, if you're trying to create a pod on Kubernetes and set a limit, so limit is a contract with the resources you allocate to a specific workload you're running. And then you would see, like you expect, or like most developers expect, that this limit would be honored by the platform. But then what happens, they find their pod or workload killed because it's ran out of memory. And they can correlate that this has to do with the limits. So like the underlying layer that operates the workload just kills it if it exceeds the limit. So this is leak abstraction. So developers have to keep in mind how this thing works internally, how like the kubelet like runs the container or like there's workload, and how it deals with the memory limits. The same thing goes with corner cases for Dockerization. Like cloud-native build packs are amazing, and people build internal Docker files in a reusable way so people can keep building the same apps over and over again, but they rarely work because of all the corner cases. Same thing with something like Terraform. You have the underlying layer that communicates with infrastructure. Like Google Cloud just made an abrupt API change that just broke a lot of Terraform code that is with Google. So these are some of the difficulties we see, but also people keep talking about it. So in real life experience, like people keep complaining about LLMs are decent at writing code, but they suck at infrastructure, which is like the worst part of coding, set up an infrastructure. And this guy here, like after posting this, after a month later, he just like decided to throw in the towel and say, okay, AGI is here once an agent can configure a Docker container, set up CI, and deploy my app. That's how frustrating it is. But like these are all opinions and like subjective opinions of why LLMs and like are suck at this kind of work. But like there's a paper about one of the reasons they are terrible at this work, and it's because they suck at domain-specific languages and configuration in general. So from this paper, you can see like a trend here where LLMs are really good at very popular languages that change not very frequently over the years, versus other languages like the long tail of DSLs and the long tail of non-popular languages anymore. They're not that good at it. At the same time, when you see like the stack, evaluate the stack, and seeing the two data sets in this like paper, which compares like asking about fresh knowledge versus old knowledge, the LLMs were already trained on, they perform really bad like on fresh knowledge. And this is the mix we get in DevOps tasks. So if we're trying to compare coding tasks and DevOps tasks on like some factors based on like everything we discussed so far, you would see that the feedback loop for coding tasks is super tight. So you get like when you have a coding agent and there's a human in the loop and it changes something, you see it, you can validate the code and then keep iterating quicker. But for DevOps tasks, it's usually much longer. So you're trying to create a virtual machine or a database on AWS, and you have to wait for 50 minutes at least for it to be ready. So then you would know if you created it with the right parameters, for example. So like this is a dumb example, but like you get the idea. The feedback loop is super slow. Another thing that's different between regular coding tasks and DevOps tasks is like the user knowledge. So users or coders or developers using these coding assistants, they have high knowledge of the task at hand, which is writing code. But less than 3% of developers are expert at this kind of infrastructure work. At least less than 3% do this full time. Also, the syntax for coding tasks is super popular compared to many domain-specific languages. And the frequency of this changes. Like coding languages change rarely, or like the syntax and the features, unlike other DevOps tool configurations, because the tools keep changing quickly. They add features, and these configuration languages configure the tools. So the more tools, the more complexity, the harder it is. And the final thing is about the context itself. So most of the context you find for coding tasks is local. So it's like you're developing locally in your machine. So everything you need, or almost everything you need, can be run locally or mocked locally. But for DevOps tasks, it's super hard because the context is mostly remote, like a bucket or configurations through the AWS API or like Kubernetes clusters deployed in production with a specific set of parameters or workloads that are not available locally. So this is the reason why LLM agents or like coding agents are really good at coding, but they suck at infrastructure or DevOps work. So what usually happens is they like run out of steam, like keep going around in loops, or they're unable to accomplish these tasks. And like this is our analysis of like at least what we learned over the past couple of years. So self-driving infrastructure. A lot of people see it this way, like Cybermen from Doctor Who. Like they're going to take over humanity, basically like push humans out and be more efficient, be more stronger when it comes to doing these kind of infrastructure tests. But like from my experience, we're developing agents and how we see them operate. We think self-driving infrastructure is going to be something like this, with a lot of minions that are stochastic agents. They sometimes spit out gibberish and they do funny things, like they keep walking around. But like when effectively managed and guided, they can accomplish great things. Like they get the job done really well with human guidance, but they're a force like to be reckoned with. So in here, like today, we're going to talk about like how we're working on this. First, I'm trying to help you imagine what a self-driving infrastructure would look like with these kind of minions. But when you're thinking about agents that operate infrastructure, like I want you to picture minions, not Cybermen. So what would self-driving infrastructure look like? So theoretically, a self-driving infrastructure would have these capabilities at least. So the first thing is you would have agents that work 24/7. So these agents can do maintenance tasks in the background. They can handle support tickets. They can tune your system live 24/7 without having people on call. And they'll be able to keep doing that over and over again. Second thing is this self-driving infrastructure will be technology agnostic. As we mentioned earlier, like having a lot of tools and a lot of cloud providers with different semantics and different ways of describing things make things super difficult. So having these self-driving infrastructure capabilities, it shouldn't like this self-driving infrastructure shouldn't care about like the tools it's using or the cloud provider. It should operate across them and like orchestrate across different cloud providers and technologies easily. The third thing is you'd have a dynamic platform UI. So as you can see with vibe coding, like you can build simple applications and interfaces really quickly or prototype more complex stuff really quickly. And the same thing would be happening in a self-driving infrastructure within your internal tools. So your internal tools would keep evolving. They would keep changing depending on the use cases, which fixes a huge problem we have with like internal developer platforms today, which is like static abstractions. And these abstractions, like they have to keep evolving. But instead of having a product manager and a developer that like put a lot of effort into maintaining this and keep changing them, because they can change it at the same rate that developers would expect the platform capabilities to evolve. So this can be done automatically, autonomously. And finally, two major, very important things we haven't tapped. So like we have super complicated infrastructure service with a lot of great capabilities, but we still don't have that much like intelligence in cost optimization and scaling. So what this would entail, like imagine the scenario, like you're running a workload in a Kubernetes cluster, but then the self-driving infrastructure would detect that this workload is like, while monitoring the data, is more suited for something serverless. So it would move it from your EKS cluster to Lambda for a specific duration with zero downtime, because this is the most appropriate kind of like compute platform to run your workload on. So this would help you reduce costs dramatically and help you with scaling depending on this. So you wouldn't care anymore about like the underlying compute, because your infrastructure is going to be able to migrate itself, like move these workloads around to save costs and optimize scaling whenever you have to deal with it. So things like scaling to Lambda and then going back to Kubernetes or scaling to zero would be easy, and it wouldn't care about the underlying compute platform specifications, because these things can be self-driving. So let me give you some examples of how this would look in practice with a couple of use cases from different personas. So having these agents run 24/7, you can do things like routine maintenance, and not the trivial kind of routine maintenance, something like this. So if you've ever had to upgrade Kubernetes after like months, like you get a new Kubernetes version every three months, but like imagine you spend a year or two like not upgrading these Kubernetes clusters, and then you have to do it all at once. So you would prompt this self-driving infrastructure to upgrade my EKS cluster to the latest Kubernetes version available. And then it would come up with a plan on how to do this sequentially, because you cannot do it at the same time. And if you're using infrastructure as code like Terraform and you're trying to do that, it would fail. Like it's not able to do this kind of incremental upgrades autonomously. So the agent will be able to do that. So the self-driving infrastructure will take this instruction, go to the cluster, read the documentation, the changelog between the different versions, migrate your workloads, test it, make sure everything's great, upgrade the like API server, keep doing that until you reach the latest version. And this will be able to can be done overnight. So you don't have to monitor it. You don't have to like keep guiding it on how to fix these issues. It will be able to figure it out. And this is what agents are great at, like figuring out like new unpaved roads to like accomplish a specific goal. So this is one thing. Another thing would be intelligent abstractions. So this is like something really painful. It's like, so different cloud providers have different ways of like naming a firewall. And so the firewall is some sort of like became a high level user intent. So if I'm a security engineer and I faced this before, like, and I'm trying to figure out, okay, where are like the firewall rules where all inbound traffic is like allowed within the cluster or like within my environment. And I'll just ask it this, and it will be able to figure out, like translate the high-level intent into lower level executable operation and figure out, okay, a firewall in an AWS, like in AWS, is called a security group. At DigitalOcean, it's called a firewall. And on like Google Compute, it's called, or Google Cloud, it's called a firewall. So it'll be able to figure this out and aggregate the results across different clouds, like in a hybrid environment, and show them to me without having to break this down and without having to define a rigid abstraction. So this is what I meant of like having more intelligent abstractions. Another kind of example is keep trying while we sleep. So if you're trying to, remember when I mentioned like creating Docker templates, Docker file templates, or using cloud native build packs don't work in every single environment, in every single case, because applications are not identical. So this is a great application for self-driving infrastructure. It will be able to containerize an app, work on iterating, coming up with a plan, creating progress checklist, keep iterating on containerizing the file, but like not just spitting out a Docker file, but actually building the image, running it, and testing the health check to make sure it passes, and figuring out issues along the way. So you can see from this screenshot, my self-driving infrastructure is able to generate a compose file to test the Docker file that's running properly, spins up a database locally, configures all the variables, all the secrets to make sure the app is working fine before spitting out the final Docker file. So it's not just like trivially generating configurations, but actually validating that these configurations work. And a self-driving infrastructure wouldn't be complete with vibe deploy. So you can already try any of the existing like coding agents to do vibe deploys on different environments. But the cool thing here is these are context specific. So you're able to vibe deploy on your own custom infrastructure on your cloud account, and it will follow security best practices. So this is the tough part, like not just vibe deploying anywhere, but vibe deploying in your own environment with security best practices. So here I'm asking a self-driving infrastructure agent to deploy an app on my AWS account with TLS configured and to configure a specific domain to point to it. And it goes through this and figures out everything. And if you can see, like it's pretty tiny, but like when it's configuring the database here, it didn't like create a plain text like password and spit it plain text into like the terminal, but created it in a file and use this file to add the password to the API without having to export this in a shell. And it created a secure password, like a long enough password. So it configured TLS and added a systemd file to restart on server restarts. And this is like, there's a lot of details involved in like vibe deploying or like vibe ops, as Ray Myers called it. So there's a lot of details, and getting these properly within your environment is hard. I mean, even developers struggle with this today because they don't have all the details and all the things they should do right at the same time in their brains when they're trying to do this. So it's super tough. So the cool thing about these examples, this is already possible today. So this is not the future. Self-driving infrastructure agents or DevOps agents are able to do this today, but is it reliable enough? Which is the biggest question. So like if you're going to try having a self-driving infrastructure with these capabilities, like how reliable are agents today? And how can you make them better? Like how can you be sure that you can sleep at night while the agent is self-upgrading your Kubernetes cluster with zero downtime? Because this is a very tough thing to do. So to talk more about like how we think about reliability and what we've learned so far, making these agents reliable in a very critical task like building a self-driving infrastructure, let me share with you how we think of an agent. So welcome, Norbert. So this is one of the minions we've been building or experimenting with, and it's the simplest possible agent. So Norbert, as you can see, like in naked minion, it thinks, and then it takes one of two actions. So just like very simple actions, and that's the first thing an agent can do. Like an agent can autonomously decide which action to take. So it can be two actions, which is the minimum, so it has some choice, or it can be many actions. The second thing is after it takes an action, it affects the external world. So it has some way of modeling the external world or observing the effects of its actions. So it can iterate, which is the second thing of making an agent. So the agent can take actions autonomously, choose which actions, and it iterates, keeps taking actions to accomplish a specific goal. And that's the third component. An agent should have an end goal or somehow a measurable end goal to be able to evaluate its reliability. Otherwise, it's super hard to say if the agent is done, and it's super hard to say if the agent accomplished its task successfully. So this is not as easy for every single domain. So in our domain, we're fortunate enough is like if you're trying to containerize an app or like deploy something or debug something, you can find in a deterministic way, like validate that the agent accomplished its goal. But like things like documentation generation is much harder, for example, or writing is much harder. So in this case, having an end goal in these agents makes it easier to evaluate their reliability and make them better, or like at least be able to observe this to see how we can improve it. So getting this out of the way, how we define agents: agent takes actions, it iterates until it reaches a specific end goal. So how we think about reliability, we split agents into two parts. You see there's the think part, which is the first thing we're trying to make it reliable. So how it thinks, how it comes up with tools or like actions to take. And the other part are the actions themselves, because you can have as many actions as you want. And we found out that the actions, like the performance of the actions themselves, affect the agent dramatically. So like the impact of having action, like the choice of actions and how intelligent these actions are, like how, for example, like you can have a very simple action that does a lot of things, or like specific actions dedicated to stuff. And there's a trade-off, because the more tools you add, the harder it is for the agent to come up with the right combination of tools to execute. Sim to a human being, like if you give a human being too many options, like their brains will just overload and like you get decision fatigue. So the same thing happens to agents. So we're splitting it between reliable thinking and reliable actions or reliable tools. Let's start with the reliable thinking. So when we're talking about reliable thinking of the agent, is how it comes up like after observing the external environment, or like the distilled version of the external environment in its memory. Like what actions would it take and in which order? So reliable thinking is more focused on the brain. And when you're thinking on the brain, we came up of like in the literature, you would see 3 ways of evaluating success. So you can check the end goal, which is the easier, the most straightforward way, because if the agent doesn't accomplish the end task, like it's failed. Like it couldn't build an app that runs, or like couldn't migrate your Kubernetes cluster, or couldn't deploy stuff on ECS, or couldn't containerize an app. So it's relatively easier to reason about the end goal because this is the task we're trying to accomplish. But then some people use sub-goals, because sometimes the end goal keep failing and you're not sure why. So if you divide things into sub-goals, you get a better idea of why the end goal is not accomplished. So this is another way to measure success. And finally, the most complicated way to measure success is the action trajectory. So the agent takes specific sequence of actions given a specific input. So a snapshot of the real world, or like the snapshot of its memory or state. And then it takes specific actions based on this like kind of snapshot. And then you evaluate this, like, is this the right course of action given the initial starting parameters, which can be fixed. So this is another way to measure like the evaluating success. So at Stackpack, we're still having gone through like all 3. We've been doing a lot of work with end goals and sub goals, but we still haven't started evaluating trajectories yet. But it's something on the roadmap, something we want to dig deeper in, because there are a lot of common like subtasks that are very common between different kinds of infrastructure or DevOps tasks. So it'd be great to see like how trajectory of agents perform on these specific like sub goals or like sub trajectories. So since now we can like evaluate like the success criteria, we know when the agent is successful. We have to pick specific metrics, because we're trying to evaluate how reliable the thinking process is. So some of the metrics people use that are generic enough and you can apply to different domains, like these kind of like the evaluation criteria. You can also apply this to different domains, not like DevOps or infrastructure specific, is pass at K, which means if you give the agent K attempts, what's the likelihood that's going to succeed at least once? So K at 1 is the likelihood that this agent is going to succeed like on a single try. At K at 4 is the likelihood that this agent is going to succeed at least once given 4 attempts. So this is a very good indicator of, can the agent actually accomplish what it was designed to do or not? So this basically asks that, like, is the agent capable of doing this or not? But it doesn't measure reliability, because if the agent is capable of doing something every one in like 10 trials, doesn't mean like every single user or every single time we're going to do this, it's going to pass. And this is very difficult for very security, like very critical infrastructure tasks. So there is also pass power K or pass at K, which means like given K attempts, what is the likelihood that the agent would pass K times? So assuming like pass to the power of K is pass to the power of 4. So given 4 attempts, what's the likelihood that the agent is going to pass 4 times, which measures more reliability, and it's a tougher metric to hit. Another thing we measure is the number of steps, because we notice that the more steps the agent does, the more it tends to hallucinate and the longer it takes it to accomplish the task. So if there's something critical I want to recover, for example, from a failed deployment or rollback, or fix something that you can do reliably with a deterministic system and you need an agent, the agent finishing its job quickly is a great thing, like it's the desirable thing. At the same time, if you're not doing a lot of state or context compression and you want to keep steps, the more steps you add, the larger the context blows up, and the more likely the agent will hallucinate and lose track of what it's trying to do. So it's like like dangling a banana in front of a minion. So the minion, when it sees the banana, it will just abandon the task and chase the banana because it's just overwhelmed and it sees something interesting and just chases it. So the agents that do a lot of steps and keep a lot of steps in their memory, they tend to lose track of what we're trying to do in the first place. And the same thing happens to me sometimes, but that's why we measure the number of steps. So the final thing is the cost of success, which like how much would it cost us for a containerization agent to be able to Dockerize an app successfully? Because as you see, like it can take on a containerization process and take 15 minutes. And I can, like, if the success rate is 50%, I could just like run it 10 times overnight until it's successful, which is fine. But how much would it cost me? Like, because what if it costs me $2,000 or like $10,000 to containerize an app? Then it doesn't make sense anymore. So part of the problems being solved is the cost of the problem itself. Like, would it cost more than it would save us to do this kind of task? Like, if you have a big migration project that would span 3 years modernizing your infrastructure, and like this thing is going, like the self-driving infra or like DevOps agents is going to cut this down into 80 months, like would the cost of doing so be, like, given the time and everything, like would it be worth it or not? So this is an example table of one of the very first evaluations we built. So the task here was being able to deploy and like a full stack application on AWS, a stateful application on AWS with like all the bells and whistles and with all the security best practices, including TLS, secure passwords, private database, button-up security groups, stuff like that. So here we tried different applications with different technology stacks, trying to make it as diverse as possible. And we measured pass at 1 and measured pass at 4. And you can see here, like we also added some custom metrics, which is something you might do, like adding custom metrics specific here. So here we wanted developers to see how fast it is to deploy these apps. So we added in the mix like a deployment time. So depending on the evaluation, the kind of metrics and success criteria I shared are very generic, but you can also add in the mix like very specific things. So once we got this, we found out like two major takeaways. The first one is sometimes the success rate is really high and it's really fast, and it doesn't mean like, okay, so this kind of task, like it's really good at it. So it's very reliable. It's almost as if it's deterministic. So this is great. So this agent is great. Like we didn't need to optimize further for this kind of like specific task. But in other tasks, we found out that the pass at 1 is very low, but the pass at 4 is much higher. Like as you see here, like if I give it 4 attempts, it would go up from 50% to just like 93%, which is very high. Like you can afford to do this in every task. Like some tasks like Dockerization, like it's not very critical. You can leave it doing that overnight, try over and over again. And every trial is just an hour, which is amazing. Like it would take me 4 hours to deploy this kind of app. But here we can afford it, but not all applications we can afford this. So pass at 4 can be tricky, like pass at K can be tricky in very critical situations. And then you need to do the pass power K to make sure it's consistent and reliable, because you don't want to rely on an agent in something critical and then you find out like it's just like hallucinated or like broken infrastructure or something. So not always like pass at K can be like misleading in some cases, but yeah, you get it. So the big elephant in the room, especially for infrastructure and DevOps tasks, like there's no available public data sets, or like there are very few data sets and with a lot of stale data out there. So how do we evaluate without data points? And like how we gather these data points? So the first thing we started is like aggregating open source code on GitHub for infrastructure. But unfortunately for our domain, like most of the code is super old and it's outdated and it's not like as high quality as you would see. And it doesn't represent the actual fact, because like infrastructure configurations, people don't usually put that on GitHub. Like they keep it in private repositories for their infrastructure, and they're like it's a closely guarded kind of code for any organization. So this is terrible. Like we weren't able to rely on this much, but it gives us a hint. And then we do synthetic data. Like we generate a lot of synthetic data, like running the agents, generating code, and using these to build evals, and they're surprisingly really good, because for very complex tasks, even a human like doesn't have like 100% success rate. So synthetic data, if like the success rate is like 70%, this would exactly be the success rate if you give a human the same time to write a data set. But the highest quality of data you can get is from real customer support cases. So we take these cases, we study them, and then we anonymize it, like go back to generate synthetic data based on these cases, like guided synthetic data. And these are the high quality you can get. And we always start seeding these data evaluation data sets with handcrafted data. So like we create use cases manually to try to spread it, like to handle corner cases and stuff like that, which is like the highest quality data we can get, but we're going to get a lot of quantity, like a higher quantity of this kind of data. So something else we do, like this is for the evaluation, but what should you do after production? So we use a lot of we tried a lot of LLM observability tools. They're all pretty much the same. We use LangFuse at the moment. So LangFuse, like, it gives you like kind of sort of traces for like the LLM workflow. So if you have complex workflows or agent, you can track everything, like all the prompts, all the sequence, the input and the output, and so on. And then you can see when something goes wrong. You would extract samples from this like production observability data and then add it as a handcrafted data point to your evaluation data. So this is very important, not just to understand what's going on in production, but to also be able to refine the evaluation data and keep like building this flywheel, making these agents better and better and more reliable. So this is the first part, reliable thinking, or like how to make the agent thinking process better. Another part is reliable tools, because we're huge advocates of the approach that like we're trying to have very few but super high quality tools, and we found out that these make the agents much smarter compared to very dumb tools. So instead of the agent taking like 20 steps to reach a specific conclusion or like do something, they can just do a single step, which keeps like the context from blowing up, and it keeps the agents much simpler by like offloading or like delegating these tasks to a more capable workflow or a tool. So here I'm going to show you a couple of examples of how we're evaluating tools, because evaluating tools is trickier than agents, because so it's sort of like it's easier to get like to build an eval data for this, like for tools, but it's harder to come up with like success metrics because they vary greatly. Like every single tool has its own success criteria and metrics to measure it with. So for the context retrieval evaluation, like here we're trying to retrieve specific parts of your infrastructure that are relevant to a question or to do precise like surgical edits to accomplish a specific task. And here you can see like we use a recall because we are optimizing for the amount of information you retrieve for the context in your machine, like in your environment. And in another case for code generation, for example, and Terraform specifically, we can't just like validate the quality of the code. We want to make sure this code is applicable in production. So we have a metric that measures zero-shot Terraform planning success rate. So we take the code, we actually try apply it in a sandbox environment and see if it succeeds, and then or like at least plan it against this environment and see if it succeeds. And this is like a high enough bar, I think, so far, at least so far, for Terraform code generation. And this is basically how we evaluated this tool call. So as you can see, like tool calls have, like you have to be creative on how you evaluate every single tool call, because like, and how important this specific task is. So you can distribute your like weight or like amount of work evenly, so you can like deal with the lowest hanging fruit first, but then like add specific like harder requirements and harder as you're accomplishing more scores. So the more higher scores we reach on specific like metrics we're evaluating tools at, the harder we're trying to make the metric or the goal, so we can keep them getting better and more reliable. So that's it. But as you guessed so far from this Cyberman, I'm a huge fan of science fiction, and I found this quote very relevant from like one of the very famous like books written so far on robotics and AI by Isaac Asimov. And it says like, there was a time when humanity faced the universe alone and without a friend, but now they have creatures to help them. And these little like minion kind of agent guys, they're super helpful and super funny, especially when it comes to some like very dull and a very like painful kind of work developers have to deal with infrastructure. So this is a great chance to try control these creatures and like make them better, so we can sleep better at night and like we can enjoy coding again. Thank you so much. So please reach out if you're interested in discussing this more. I would love to show you what we're doing and talk about these kind of like agent evals, because they're super tough and they're super interesting. So yeah, this is my LinkedIn. Thank you.
Thank you so much, George. That was awesome. Yeah, that was really fun. It resonated a lot. And right at the end there with the Asimov quote, like I recently had a project where I had to hack on something for a couple weeks, and it was just me and some bots, and it felt different than back in the old days. Or like I feel like I've got like a bit of a thought partner, and I like write up like mini specs and send it off to my minions in that case to do work, and it was a very different experience than kind of doing it solitary. I do like working with humans, so I like having both. I don't just want to be locked away in the basement, but yeah, it's really fun. So on before you go, I got a couple questions here. So this is one. Have you considered using reinforcement learning techniques to guide these agents and potentially improve their success rate compared to relying on rules and like? Any thoughts there?
Yes, definitely. Yeah, definitely. Like one of the major challenges with agents is picking, like at least the evaluating, like or improving the thinking part. Like we talked only about evaluation, like not techniques to improve the performance, but like one of the major things with thinking is choosing the right tool at the right time. And this is where like reinforcement learning policies are super important. Like you can optimize the tool choice based on like successful runs, but like the trick here is figuring out like how to create a reward function that optimizes for like the success rate. Like would you incorporate, like there are some papers that incorporate a mix of have like taking the end goal and the process at the same time, and like add a mix of like a weighted sum for like accomplishing sub goals and end goals, for example, in the reward policy. But also you need a lot of good data points to be able to train this. Yeah, so this is definitely something we're considering and working on.
Yeah, I kind of picture like having minions in these isolated worlds to be able to try things out and be able to kind of learn over time and do the Alpha Zero thing, but in the world of DevOps. That's really fun.
Yeah, but it's super slow. Like we have cloud sandboxes and we let these agents, like we have a minion farm where these agents are run freely, but like it takes sometimes like 15 or like up to 60 minutes to accomplish a specific task, which is super slow to generate enough data, enough realistic data.
Oh man, that's fun. So if I'm newer to this world, like how do I build the trust to the point that I can actually sleep at night and allow this system to go off and be, self-healing and doing things and not having me, having my mind wake myself up at 2 a.m. worrying about, what happened? How do you kind of go through and build that trust?
So we have two things at the moment. We're still discovering, like we're still exploring this, but like one of the things we found out that really helped and is like showing the users or like the developers the thought process of how it comes up to these conclusions and how it's thinking about accomplishing this. So the more you add tracing data, like how you, for example, like how we're debugging the systems, the more we show users this kind of like internal workings, how these things are built, how they're evaluated, how they think, the more trust they evolve. And like it sets expectations right to the right time. So like the more you see them considering a lot of angles you never considered before, like storing secrets in encrypted files and not like in plain text and stuff like that, the more you realize, okay, these things are actually more reliable than I thought, and then you would trust them more. So this is one thing. Another thing we're doing is we're starting like opening up like these benchmark results. So the first time we launched an agent last year, we published with it like a big table with what it's good at and what it sucks at. As you can see, like we added a row of like, okay, this cannot deploy Supabase. Like the success rate is 0 even after multiple trials. So we show developers that they think like which scenarios these are optimized for and which scenarios we're evaluating for and which other scenarios are still not very explored. And you can trust them to do these kind of things well.
Got it. Nice. And then if I'm a developer that hasn't done the DevOps thing yet, do you feel like the world of AI makes this like more approachable? Like would you like recommend that they actually start getting into DevOps now and the water's warm?
Yes, definitely. I mean, like a lot of developers I meet are scared of doing infrastructure work because they don't want to mess something up. Like they don't want to leave a firewall rule open or like leave a database public and so on. And you would see like it's much easier to align like the like these kind of agents or like these kind of chatbots or like the code generation, whatever you're doing, with specific security policies. So like the defaults are really more secure than what an average developer would do, because developers are scared of touching this kind of work. But I think now it's more manageable. At least you can think, like you can check the thought process of these agents and you can do it yourself. But like it's very educational. Like I've learned new AWS CLI commands by watching these agents work. I didn't know, for example, there's a subcommand for you to wait on a specific resource to be ready. Like I always wrote a bash script or like use something else.
That's fun. Awesome. Well, George, thank you so much for taking the time and staying up late to show us all of this stuff. We really appreciate it and look forward to chatting on Discord and the like and continuing the conversation.
Amazing. It's my pleasure. Happy to be here. Thanks for having me.
Yeah. Cheers. Okie doke. That was great. So next up, we're going to be getting on to the 7th session of the day. We're going to be chatting with Gene, but just to show you what's happening elsewhere as well in the AI Today world, there's going to be chat about deploying Copilot and Cursor for 80 developers and seeing how that's going. And then there's a bunch of, 2 different things in the tools in action track that's going to be talking about how to go through and refactor legacy code, and the world of AI for the other 70%. But we're going to get to our world again, and let's move that over. And so I was super excited about this session when I saw that the talk was going to happen. It's lessons learned vibe coding with Steve Yegi. 12,000 lines of code a day and more, right? Kind of almost a scary amount, to be honest, when I first saw it. But Steve Yegi is an infamous programmer. I actually worked with him at Google. The first interview I ever did was with Steve, talking about this Rhino on Rails project that he did at Google, which was all about doing kind of Ruby on Rails, but with JRuby. Fascinating project a long time ago. Now, of course, he's working at SourceGraph. He built this project called Grok within Google. SourceGraph has a kind of external version, and he joined there to do Cody and their new AI coding tools, the tools that they've got. They're called Arc or AMP rather. So it's been really fun to kind of see him get out there talking about chat ops. And Gene got to work with him on this, and has been doing this stuff himself. So he's been studying technology transformations at large companies. He's been a founder and CTO at Tripwire and the like. And I'm just really excited to welcome Gene Kim to the stage. Gene, how are you?
Dan, great. So great to be here, and always happy to share stories about Steve Yegi with a former someone that he's also impacted as well. So that's been,
absolutely.
I trust he was as interesting back then as he is today.
He's always been a character, I think. I think that hasn't changed. That's for sure. That's awesome. Well, Gene, I'm really excited to kind of sit back and see what you've got to share with us, and then I'll be back at the end to chat a little bit more. But let's take it away.
Fantastic. Thank you. Yes. So I've had the privilege of studying high-performing technology organizations since 1999, and that was a journey that started back when I was the CTO and founder of a company called Tripwire in the information security space. And so our goal in studying these high performers, it was those organizations that had the best project due date performance and development, the best operational reliability and stability in ops, as well as the best posture of security and compliance. And so we want to understand, how did those amazing organizations make their good to great transformation, so we could understand how other organizations could replicate those amazing outcomes. And so, as you can imagine, in a 26-year journey, there were many surprises, but by far the biggest surprise was how it took me into the middle of the DevOps movement, which still remains so urgent and important. I think the last time that we've seen any industry disrupted to the extent that all our industries are being disrupted today was likely in manufacturing in the 1980s, when the U.S. auto industry was upended with the entrance of Toyota into the automotive marketplace. And so I got to work on the DevOps handbook with Patrick Dubois, worked on something called the State of DevOps Research with Dr. Nicole Forsgren and Jez Humble. And more recently, I got to hang out with Steve Yegi, who I met last June. And I cannot tell you what a fun adventure that has been. So what I'd like to do in the next 25 minutes is share with you what I've been up to lately, what Steve and I have been working on together, and share what vibe coding has to do with DevOps and the Dora anomaly, and really describe what vibe coding has done for me. I had mentioned earlier, I've never had as much fun as I'm having today because of what AI-assisted coding can enable. And so I've written a bunch of books, including the DevOps Handbook, which I mentioned before, the Phoenix Project, the Accelerate book, as well as Wiring the Winning Organization. And so we had mentioned Steve Yegi, and so many of you may know him through one of the most best depictions of the great Amazon API re-architecture in the early 2000s, where they went from being able to do hundreds of deployments per day in the late 90s, grinding to a halt where they could only do tens of deployments per year. Most deployments didn't even finish to later they were able to do hundreds of thousands of deployments per day by 2011. And so one of the best depictions of this was this famous memo that Steve Yegi described, saying how all teams must henceforth communicate only through APIs, that they can only communicate through these processes. No other form of inter-process communications would be allowed, and anyone who doesn't do this would be fired. And of course, in the Yegi style, he said number 7 is obviously a joke, because Yegi doesn't actually care whether you have a great day or a bad day. And so that famous memo actually landed him on the front page of the Wall Street Journal, because that was actually meant to be posted privately on Google Plus, and he accidentally set it to public, and resulting in a 2 a.m. call with the Google PR managers. Anyway, so I met him in 2024 because of the work that he was doing in what he was calling chat-oriented programming. And as a result of our conversation, he wrote this article called "The Death of the Junior Developer," which was so utterly interesting and really described kind of what is happening to the workforce, what could be potentially happening. He later presented at the Enterprise Technology Leadership Summit. This is a conference I've been running for the last 11 years, describing how coding is changing out from underneath us and how organizations need to get ready. And one of the things that we found that we had in common was this belief that the days of writing code by hand are coming to an end. And so some of you saw the talk earlier from Dick about he was the MVP champion, and this is Dr. Eric Meyer. So he was in charge of C#. Before that, he was part of Visual Basic. He wrote the hack language at Facebook, Meta, and he gave us this amazing talk sometime last year, who described how time is the most important thing that we have as humans. It can be neither stored nor created, and so if we can find ways to save time, we have to take it. And he said that. For so long we thought as developers that we would be safe from automation, but in any sort of analysis, we're finding that code generation is actually one of the things that AI is best at. And if we are the last generation of developers who write code by hand, let's have fun doing it. So both Steve and I loved this talk, and Steve, more than anyone I know, has really adopted vibe coding into his daily work. He's now writing 12,000 lines of high-quality code for production that's well tested. He's spending $300 to $500 a day on 3 to 5 instances of Claude Code or SourceGraph AMP. That's how he's racking up these sort of numbers. And what's astonishing here is that all of the practices that he's using, right, all of us can use in our own daily work to have more fun, be more ambitious about what we can build, do things faster, and explore a much larger option space. And so, what is our definition of vibe coding? It's really anything besides typing in code by hand. So that's a very expansive definition. So vibe coding obviously was coined by Dr. Andre Karpathy, not so long ago in December. And already they're talking about at Google, actually, instead of fixing code, just pulling the slot machine lever like we saw earlier today, right? And just generating a new solution. When the cost of creation drops, it brings into possibilities, ways of solving problems that just simply did not exist before. The Cloud Code team, they were recently, Boris and Catherine Wu, they were on the Latent Space podcast, and they described how 80% of all code for Cloud Code was actually written by Cloud Code. And they're citing within Anthropic, somewhere between a 2 to 10x increase in productivity, or at least compression in terms of how much time is required to do things using Cloud Code versus writing it by hand. So here's the value that we put into the book that we're working on. We call it FAFO, faster. We can build things that we want faster. We can be more ambitious about the things that we can build. 3 is we can do them alone. In other words, we don't have to rely on a team, or worse yet, a team of teams, right? We reduce the cost of coordination, as well as this other cost of it's very difficult to read other people's minds, even with AI. So if you can do things alone, right, that creates a whole bunch of independence of action that didn't exist before. We can also have so much more fun doing it. We know that from decades of benchmarking is that when we are more productive and we have more fun, that is a magical combination. And then one of the things that I will try to convince you in this session is that the highest value of all is to be able to explore more options, to have more swings at bat, to explore more of design space, because we can do things so quickly and easily. So just as a personal example, in the last 6 months, I did my first large-scale statistical analysis in Python. So for the last 20 plus years, I've used primarily SPSS, which is one of the best that 1970s technology could give us. And I did it in Google Colab. I did it in Python, a language that I've only spent maybe 100 hours in my whole career using. And it was the first time again that I did things where I have just decades of muscle memory doing SPSS. That was magical. I resurrected a new data pipeline from Twitter, which Twitter broke in 2023. But in support of the book, I was able to get that up and running through if this, then that. And I can't help but notice that anyone who figures this out and posts a repo who talks about it has a repo taken down. So if you have any advice on how one can actually talk about that without some sort of takedown notice, I would love to learn. And I've fixed bugs and tools that I haven't touched in 2 years that have been bothering me, all possible because of primarily coding agents like GitHub Copilot, like Sourcegraph Cody, and so forth, and Augment Code. So I also wrote 3 iterations of a writer's workbench. Actually, I haven't mentioned it, right? So Steve and I were working on this book called Vibe Coding. It's coming out in fall. In summer and fall, and there were 3 iterations of it. The first one was just a JavaScript app to reduce the amount of copy and pasting required to sling these copy paste prompts and data from one tool to another. I wrote the second generation was a Google Docs add-on, which I've never written before. I wrote that in 3 hours inside of Google Apps Script. And that was great. Both Steve and I used it, but it was so slow. It would take somewhere between 15 to 30 seconds to open up files, to copy things to clipboards. And so I wrote a third iteration in a terminal application, sort of like Claude Code. And that has been amazing. And so really the net effect, like so many of you developers, is that there are nights where I can't sleep because of all the things that I want to build. I'm having to force myself to put down the keyboard and go to sleep so I can have a healthy life. But it's so full of danger, as you know, right? AI generated code can quickly become non-modular. They can create these eldritch horrors, these incomprehensible code bases that are impossible to understand, let alone change. You can create simple changes where AI builds upon its own unreviewed code, creating tightly coupled systems, no matter how many guidelines you give it. And then, we know that teams working in complex, tightly coupled architectures, the literature has said is that teams working in bad, tightly coupled code bases are 9 times more likely to be fired or quit, right? Those same things can happen when we're working in AI-generated systems, which can turn nicely modular code quickly into a big ball of mud. And we know that if you don't have fast feedback loops, we know that fast feedback loops are important to get feedback on our work and development. But with AI coding, with Vibe coding, we need even faster feedback loops, right? That because as the time to generate code goes down, our feedback loops have to be ever much more tighter, and we need that happening in our most inner development loops, right? Measured in seconds, not minutes. And so I had mentioned this Vibe coding book. This is coming out in the fall or summer or fall. And again, I have learned so much working with Steve on this book. And again, I've never had so much fun as right now. So I mentioned this writer's workbench that we wrote to help with the draft generation and critiquing process. What's remarkable is that we burned 70 million tokens in 30 days. That's 3,000 LLM hours. And this was just amazing. When I was writing the preface for the book for my section, I was stunned to find out that the first line of code was written only 30 days ago. So what happened in 30? Life moves fast in the AI world. We found that even in those 30 days, we went through the whole life cycle of software where it was exhilarating and working. It turned into a haunted code base that was impossible to change. And I was able to resurrect it, to support this production need of getting the book out. But again, there is a very incredible orthogonal relationship between, say, Vibe coding and Vibe writing. It essentially turns the it is like a slot machine, right? As we saw in the vibe coding demo, right? Is that you have such high upsides, but also infinite downsides. In the slot machine, you can only lose the amount of money that you put in. When it comes to vibe coding, the slot machine can actually reach into your pockets, into your bank accounts, right? And destroy your code base, which actually almost did happen to Steve before. So there are so many interesting problems that still need to be solved, right? How do you gain assurance of code functionality when it's no longer you typing out by hand, and maybe even in languages that you don't know very well? What do you do when all the jobs we had when we started our careers are going away? This is actually what someone who is head of dev platforms at a foundation AI lab said, right? How do we get our own organizations ready for this incredible new technology? And for that matter, how do we measure the value that Gen AI creates for developers? So let's move into the second portion of the talk, which is about how we measure value. And so this is one of the things I'm most professionally proud of in my career is working on the state of DevOps research. I started this with Jez Humble in 2012, and Dr. Nicole Forsgren joined the team in 2013. And so this is a cross-population study that spanned over 60,000 respondents over 6 years. And so the cross-population instrument is the same technique that they used in the health profession, right, to establish the link between smoking and early morbidity and mortality. So we use the same instrument to try to find out what do high performers look like and what are the things that correlate or even predict performance. And what we found that for 6 years in a row is that high performers exist and they massively outperform the non-high performing peers. And so, we know that high performers deploy multiple times a day. So that's 2 orders of magnitude faster than their peers. But more importantly, they can deploy in 1 hour or less. In other words, how quickly can we go from code committed into version control, into integration, through testing, through deployment, so customers saying thank you. Again, that's 2 orders of magnitude faster than the peers. What's remarkable is they're getting far better outcomes. When they do a deployment, they're 7 times more likely to succeed without causing a 7 outage, a service impairment, a security breach, or a compliance failure. And when something bad does happen, which Murphy's Law guarantees, they are able to fix things in 1 hour or less. That's 3 orders of magnitude faster than the peers. And so what we know now from 6+ years of research is that the only way that you can get these small, these amazing reliability profiles is to do smaller deployments more frequently. And so we know that over the years, these high performers, because they're integrating information security objectives into everyone's daily work, they are spending only 1/2 the amount of time remediating security issues. And in addition to these great technology measures, they are twice as likely to exceed profitability, market share, and productivity goals, or twice as likely to achieve organizational and mission goals, regardless of how they choose to define it. And so it just shows that, when mission achievement requires work that we do in the technology value stream, DevOps helps with the achievement of those goals. So what we know from the Enterprise Technology Leadership Summit, the DevOps Enterprise Summit, is that this is not just for the big tech companies. This is across every industry vertical, across whether it's profit or not profit. And, we know this is true in pharmaceuticals. So this is from Pfizer describing how they're elevating the productivity of thousands of developers across all the parts of Pfizer, whether it's research and development, pharmaceutical development, sales and marketing. Vanguard is an organization that has $9.5 trillion of assets under management, 10,000 plus developers. And Siemens, they give us an amazing experience report showing that how they're applying the same techniques for computed tomography inside for the fleet of thousands of CT scanners inside of hospitals. And by doing that, they were able to reduce the time to get software into the certification process. They could do it every day versus spending up to 6 months to get software ready for certification. So always being certification ready. So are we there yet with vibe coding? No. In fact, one of the case studies we put in the vibe coding book was a friend of ours, Luke Burton, who was at Apple and now NVIDIA, describing how he had written firmware uploading software for his CNC machines. So those are the metal grinding machines. And had he not been paying attention, it would have actually required a factory reset of a machine that's hundreds of pounds, requiring access to the factory panel. So just showing how so much vigilance is required. And so, just to show how potentially dangerous AI is, there was something that really peculiar that showed up in the DORA report. So this is the DevOps Research and Assessment Organization. That was the state of DevOps research was acquired by Google Cloud. And they found this astonishing finding that said the more AI you use, the worse throughput got and the worse stability got. And when I read these findings, I was just astonishing, right? In fact, I got in contact with them, and and the reason is that it just does not square with my own experience, where I feel like I am 10, 20, 30 times more productive with AI assist than without, right? What could explain, this anomaly? And scientific anomalies are often the source of the most significant breakthroughs, including Mercury's orbit revealing the true nature of gravity, the eclipse in 1919 validating Einstein's discoveries. So our goal is to, we're assembling a dream team of researchers where our goal is to see if we can explain the anomaly, right, and actually be able to tease out what value, we can actually get from Gen AI. So here's two hints. This is Fernando Cornago. He is Global SVP of Digital Tech at Adidas, and he described a 700-person pilot that they used internally. And one of the great piece of evidence that he was able to show was that it requires loosely coupled architectures, requires fast feedback loops. And when you do this, you can get a 50% increase in happy time. So this is time that developers, they appreciate. They're working on things that advance their craft, that help advance the mission goals, right? Unhappy or annoying time, right, is, dealing with brittle tests or dealing with environment issues or dealing with, impossible to understand test failures. And so he's describing that they're finding like a 30% reduction in pull request times. And so, we know there's something there, right? And that architecture and fast feedback loops are a discriminant. Bruno Passos, this is Bruno Passos. He is head of dev platforms at Booking.com. They have 3,000 developers. And one of the things that they found in their year-long plus pilot is that they're observing 30% reductions of merge request times, just like Adidas, and also 70% reduction in diff sizes. And so we know that the smaller diffs, the faster we can improve them for whatever reasons, right? Developers being disciplined about using vibe coding techniques, they're also putting in merge requests that are smaller and easier to prove. So more research needed there. And this is really what we're hoping to tease out in this study of Gen AI and developers. So let me share with you what excites me so much about vibe coding, which is what we're calling FAFO. Be able to do things faster, be more ambitious of what we can build, be able to do things alone, have more fun doing it, and have more swings at bat. So what's interesting to me is that clearly I can do things faster. In fact, I was able to, in my first pair programming session with Steve Yegi, I was able to write a program that took these excerpts I generated from screenshots of YouTube videos and turned them into video excerpts I could post on YouTube, which is actually how I first met Dr. Eric Meyer. My first interaction with him was commenting on his video. I did that in 42 minutes. And so my reflections on that is that, one, it was faster, but two, it enabled me to do things that were more ambitious. In other words, that video excerpt creator was something that I've always thought about. I had wanted to build something like that for years, but I always slotted that as a next month activity. And maybe it was because the perceived benefit wasn't high enough, or maybe the difficulty made the juice not worth the squeeze, or maybe there was some other opportunity with a higher, more immediate payoff that I chose to do that instead of writing the video excerpt creator. So these are all economic decisions about how I chose to spend my time. That's actually not how my brain works, but economics gives us a great way of talking about how why we do things one thing versus another. And so the fact that I could be more ambitious about what I could build and do it in less than an hour, not days or weeks, just opens up worlds of possibilities in terms of what we can do. In fact, the Cloud Code team described that one of the things they've noticed is that a lot of pull requests, they never make it to the backlog. They're just done in that hour, just because it's easier to just do it then than it is to deal with all the bookkeeping, and putting the backlog where it may never, ever get done. So allows the combination of ambitious and faster is very, very powerful. The third dimension is to be able to do things yourself. So Steve told me the story last year that I found very impactful. He was talking to his then head of AI, who showed him a multi-class prediction model that he had trained and deployed in a single day with the help of a coding assistant. What's really remarkable about that story is that had that happened the year prior in 2023, that would have been a 6-week university senior level intern project. So it was great for the head of AI to be able to do it himself. Maybe not so great for that junior developer who lost an opportunity to do something amazing, but it just shows how doing things alone allows us to reduce the cost of 2 very important taxes. One is coordination cost, right? Every time you have to work with another person or another team, you have to deal with synchronization, coordination, prioritization, reporting, all these things. And that's not free. The second one is that whenever you're working with someone else, you just can't read someone else's mind, right? And so being able to lower that cost of not avoid that altogether by doing things yourself, right, has tremendous value. 4, we can have more fun doing the work. Without a doubt, my personal experience is that using vibe coding techniques, I'm having so much fun. So it's a very addictive thing, vibe coding, right? Is that you have intermittent rewards like a slot machine, right? And that's actually the most addictive pattern that causes addictive behaviors. And so I think this is why so many people are saying, I'm up till 2 a.m., right? Because it's just so fun. And the last thing I want to share with you is explore more options. And I want to share with you, so this means having more swings at bat, research more alternatives, prototype more ideas, analyze more risks to avoid going through one-way doors that you can't get back through if you choose the wrong door. And so this is all what happens when we can lower the cost of experiments. And this makes it easier to expand the frontier of what you can build. And so there are 3 key ideas in economics. One is the time value of money, meaning $1 now is more than $1 tomorrow. 2 is portfolio diversification, right? Don't put all your eggs in one basket. And the third is option theory. The more uncertainty you have, the more valuable it becomes to defer a decision. In other words, defer the decision until you have more data. And so when things are as uncertain as now, you don't want to get into long-term commitments. You don't want to get into a 3-year outsourcing contract, right? Because everything can change next month or even tomorrow. And so Steve Yagi is the person on the lower right. Dr. Steve Spear is on the upper left, and the person who is a pioneer in modularity and option value and modularity is Dr. Carlos Baldwin. And we got a masterclass in understanding how to identify option value, how to measure it. And it comes down to this incredible formula called NK divided by T and sigma. And so we all know the value of modularity, and I feel like option value tells us why. N is the number of modules that can be worked on independently. K is the number of parallel experiments that can be run on each module. T is the time required to actually perform an experiment. And sigma describes the risk-reward uncertainty. And so when sigma is 1, basically you know everything ahead of time, right? You don't need option values, you don't need experiments, right? Because you always know what the right answer is. When sigma is infinite, like right now, right, option value is very, very high. And so we want the most number of modules that we're going to work on independently. We want to perform the most number of experiments, and we want to spend the least amount of time performing experiments. And so this is a scalar value that if we can increase modularity, increase the number of experiments, decrease the amount of time required, right? This creates exponential value in terms of the option space that you can explore. So think of the slot machine, right? You want to find the slot machine that's paying out the highest, right? And you want to defer your decision until you know which slot machine is paying out the highest. So, yes, the time has never been better to be a developer. So let me leave you with this. I am so eager to find out how leaders are using this amazing new technology to help their organizations win. Bruno Passos from Booking.com, he'll be presenting at the conference I'm running in September in Las Vegas. So will Fernando Cornago, the SVP of Digital at Adidas. We're hoping to get some of the other amazing case studies of how people are really driving the frontier of performance. And so if you are interested in that, please join us in September. The help I'm looking for is anyone who can share experience reports about how they are using AI to generate amazing solutions and help your organizations win, please contact me. If you're interested in anything I've written, including excerpts from the Vibe coding book, just send an email to realgenekim@sendyourslides.com. Subject line, let's do DevOps. I think I'm not sure if the Gen AI one took. Just send me that email and you will get an automated response in a matter of minutes. So I thank you so much for your time, and I look forward to your questions.
Okay, thank you so much, Gene. That was really fun. It seems like you got across the fun that you're having in this new world.
Oh my goodness!
Awesome.
Yeah, like I said, I've never learned as much as I have right now, and I've never been having much fun in terms of like not just coding, but all the research around like what does it take to create the conditions so that people can actually get value out of this new amazing technology.
Yeah, totally. It resonated a lot. I feel like I can dive into areas that I've not, like you were talking about getting into Python. I've had the same thing. The whole T-shaped developer, right?
Yeah.
Like it's totally changed what we're able to go into and just have confidence in going into, which is really fun. I was talking to a developer who, their company has a mono repo where before it'd be like, here's the Rust developers and they live within this part of the source pool. Right? And then now they're diving into each other's code and they still need the expertise, right? They're still getting reviews from the people that really understand it. And so you get into this kind of virtuous learning loop, which is really fun.
No, it is absolutely. What a time to be alive.
Right, totally. Okay, I want to pull up a question here. We often talk about the time of like writing the code, so to speak. But Patrick was curious how much time you spent reviewing compared to, the actual code generation.
Oh my gosh! Oh, what a great question, Patrick. So yeah, so for Yegi to post these numbers like 12,000 lines of code committed, he's reviewing 100,000 lines of code. And in fact, he's obviously not generating any of the code, so all his time is spent reviewing. And so this is for a multi-million line code base called Wyvern. It's this game that he wrote 35 years ago. And it's something that he knows intimately. And so often when we were in our book writing sessions, right, he's watching, the output of, 3, back then it was only 3 coding agents. But it just shows that, I think what we need to get good at is review. I had mentioned, burning 70 million tokens while writing the book. And to write 3 paragraphs, Patrick, when we worked together on the DevOps handbook, so much of it was interview, and then one of us would take the lead at generating the first draft, right? To be able to put in a transcript and say target, 3 to 5 paragraphs, right? And go from 1 model to 10 models to 50 models simultaneously. You're expanding the option space, right? You're actually increasing K and decreasing T, right, which actually allows you to find that lightning in a bottle. So we would review 30 to 50 pages, right, to cobble together 3 to 5 paragraphs. So it just shows how time goes from generation into reviewing and selection. And I think it just shows the thing that becomes most important is like judgment and taste and knowing what you want.
Yeah, that makes sense. You're talking about the workbench. And you're adding all of this code really, really quickly. How do you find the process kind of scaling over time? And you mentioned just then that Steve Yegi with Wyvern, like he has the whole code base in his head, so he can be the reviewer and the like. Like, how are you finding things as it's scaling, and the individual human maybe doesn't have the entire code base within their head even quicker? With
it went great until it didn't. Right? I remember there was one point in time where I needed to paralyze the ranking function, right? I was trying to decrease T. And I looked inside the code and it was this 3,500 line function, right? Where I didn't even understand how the output files were being generated. I didn't understand the function signature. I spent 20 minutes trying to understand it and then forgot it because it was just so incomprehensible to me. It took me 2.5 days during a writing deadline to actually Steve had to, he had a medical emergency. And so I used that time to actually fix the code. Because so that's what it took to resurrect the code base into something that could change again. And so it just shows that for any given solution, there are infinite ways to solve it, and AI will find the most alien ways to solve it if you're not careful. And so I think I thought I learned my lesson, and I actually tried to build something like a Java Swing UI, and I just found that the AI would just find any way to put pixels on that screen. I'm like, no, you're only allowed these 4 functions to get things onto the screen, and it just takes that level of vigilance. Otherwise, you have a lot of cleanup to do. And when you're relying on the functionality, it's a nightmare to try to recreate it. Anyway, so I think any developer will resonate with that story.
Totally. No, that makes so much sense. And then you had on one of your slides talking about, test-driven development. What was that process like? Because we were chatting earlier with someone about kind of the chicken and the egg of, developers really don't like writing tests. So can the AI write the tests? And, there's all these tests. So can the AI take the tests and write the code?
Yeah, I think, right? I mean, what is it? Like all tests are specifications, but not all specifications are tests. And in my opinion, I think it's crazy, absolutely crazy, not to write the test first. Because at that point, you not only have a specification, but you have something that is testable. Right? Because it concretizes your interface. You're testing the outputs of that interface, right? And you're forcing the AI to stay in that box. I mean, that solves so many problems in my experience, right? That goes so far in terms of like preventing you wake up and you see a room full of AI generated horrors.
Yeah, no, totally. And you're talking about how with the swing example, how it found alien ways just to put pixels on the screen.
Yeah.
And I see that all the time with tests too, where if you don't write really good tests, it'll find lots of ways to kind of get around to make that test pass.
Oh yeah, including disabling them.
Wonderful ones of deleting code and putting pass in there and the like.
Yeah, in fact, there's one learning that we put into the book, which is there's something that you have to be so vigilant about is the fact that AIs are bad at instruction following, right? That's well known. But the fact that essentially AIs are really good at hijacking the reward function. And so when you say make these 10 tests pass, right, it might do a great job on the first 6 or 7, but as it's running out of output context, right, it will often say, all right, I made all the tests pass, but just disabled the last 3, or because it wants to be helpful. So those are things that I think all these things suggest we really want to work on small tasks. There was a great line from one of the other sessions that said, target your output generations to be about 100 lines of code long. I don't know if that's the right number, but yeah, it's probably closer to 100 than 1,000, right? And so another reason to sort of shrink the ambition of the tasks.
Yeah, makes sense. Okay, got another question here for you. So what strategies have you found work for avoiding cascading design problems? And what are some SDLC formats with vibe coding that you have found effective?
Yeah, I think one of the things that we know from the state of DevOps research is that architecture is one of the top predictors of performance. Meaning that my recent understanding of this is that it really is about having independence of action. You want pieces that can work independently of each other at the same time without any ability to interfere with each other. And I would say most of the vibe coding disasters that I've had are where you'd have 2 pieces that were once separate somehow get stuck together again, right? And I think anything where you can sort of signal to the AI, right, whether it's in the Claude MD file in something, right, it's like work only on the files that I give you, right? Don't backdoor yourself into another module. That's I think that's how you prevent the cascading part of design problem. And I think the other thing that sounds so obvious, but every project, every endeavor, you can decompose into a task tree or task graph. Just thinking through what that is, right, and decomposing it, and then sort of starting at the leaf nodes, right? That's where I still catch myself making errors where I do that, generate a plan, and then I have it do too much when I really should just be sticking to the leaf nodes because it's easier to verify, it's easier to validate as you go, and it's easier to spot when it's coloring outside the lines.
Yeah, makes sense. Awesome. Thank you so much, Gene. That was great information. Look forward to reading the new book. And thank you again for taking the time to join us today.
Very good. Well, if you're interested in free excerpts, just send an email to that sendyourslides.com, and I look forward to hearing from you all. Thank you.
Awesome. Thank you. Okie doke. So next up, it's our final talk in the track. It's one I've been waiting for. And so Ben Galbraith is someone that I've gone to work with across multiple companies, including our own and large companies, and now at Tessel, where he's head of product, and he's going to be interviewing Des, who's been a pioneering leader for all of his career. And Intercom has always been at the kind of bleeding edge of AI and kind of all technology. And so let's welcome them both to the stage and have a discussion about Intercom's agent journey and so much more with AI. Welcome, folks.
Hey everyone, glad to be here. Des, how are you doing?
Good, yourself?
I'm doing great. I'm doing great. If you don't mind, I'd love to embarrass you and give a little bit more of an introduction just for folks who may not be tracking you super closely. Des is, of course,
I'm also laughing at the difference in the photo you presented and the state of me today. I would have shaved. Sorry.
We'll update it for the next one, man. So Des is the co-founder and chief strategy officer of Intercom. And as Dion was mentioning, Intercom helped define modern in-app chat and is now redefining what AI-first customer support can look like. And under Des's leadership, Intercom was one of the first to fully commit to an autonomous AI agent. It's part of what we're going to be talking about in a few minutes. And they've been pushing what's possible for an agent in production. Also want to point out that Des is an active angel investor. Des, I think everybody says that, but his portfolio includes companies like Stripe, Miro, and Notion. So the real deal on that side as well. And he's a leading voice in all things product startups and the future of AI-powered software. So sorry to embarrass you, Des, but with that, we're going to unpack this real experience of what it's like to use AI to build and scale an autonomous AI agent. And then we're going to have a conversation about what it means for software teams and for coding and for the industry more broadly. So let's dive in. Des, you've talked a bunch about just the shift that you went through from an initial prototype that you did really early to scaling this thing into production. And I wonder, just to kick things off, if you could just share what you learned about that journey from an impressive boardroom demo to actually using this for real.
Yeah. The biggest thing we learned is AI building product in the age of AI is extremely different. That's it in a nutshell, and I'll unpack that now. So we had many different impressive demos of Finn, which is our AI agent for customer support. The problem with most of them, the story goes something like ChatGPT launches November 30th. By December, we had versions of AI features in our inbox. We were the first people to basically build OpenAI GPT features into our product.
Wow.
We had the first prototypes of Finn in January, but this was on GPT 3.5. We couldn't kind of safeguard against hallucinations. So what we could do at the time was give you a really impressive demo as long as we could control what you said, and it looked great and it performed well as long as you didn't put it into production. And I think for what it's worth, I think there are still many AI companies figuring this out.
I was going to say, sounds familiar.
Yeah. It was really when GPT-4 dropped was the beginning of like, oh well, we can actually control this. We were able to safeguard. We have like this pretty robust torture test of all the things you don't want a customer support agent to do. You don't want it to give the wrong answer. You don't want it to make up an answer. You don't want it to take an opinion that it shouldn't take, whether it's political or about the world. You don't want it to recommend your competitors. There's so many things you would never allow a human to do before we even get into like the fine tuning of like, ooh, let it speak in my brand's tone of voice. Like they're all kind of nice to have. But it was really only when 4 dropped, which was March, that we were able to release a fully autonomous agent that actually you could put in front of your support team. And that was like the best thing I could say that we learned was like AI product is just fundamentally different in that, the average software development lifecycle goes something like, talk to customers, a bit of research, go off into the forest, wireframe some stuff up, come back, start building, run a beta test, ship it, we're good. And if it's used, even better. And the AI software development lifecycle is a lot more like brainstorm about all the things that might be possible, try, see if you can get it working in a sort of internal pilot, then commit to building it, build it for real, hope to God it works in the wild. Once it's live, you have to test the hell out of it anyway, because we have like 30,000 customers. So if there's edges or wrinkles in Finn, they're going to find it. And then you kind of are after that, you're in this like constant process of iteration. So like when we launched Fin, I think it was resolving maybe 25% of our customers' support conversations. Today, it's doing about 58, 59%. That's been an entire process of improving Fin behind the scenes based on what we see in the wild. And so it's like every single thing you assume about software is usually would have hinged on this idea of working in time boxed or scope boxed chunks. It's all out the window. Everything is different in AI.
Well, first of all, Des, I'd love to see the torture test. I imagine that's not something you make public, but oh my God, it sounds fascinating.
We don't, but you could imagine, it's like if you're trying to do it yourself, like let's say you're trying to do one for Tesla or for any of your customers, I would say to you, there are like 3 or 4 categories of things. Like, show me the last 20 hard questions that your frontline support couldn't answer. They'll go in. Show me the 10 most common questions. They'll go in. Then let's talk about like security conscious, like, like as in you don't want to get prompt injected or anything like that. So you'll have a set for that. And then you're into like what happens with a sales conversation? Do you want your customer support like leaning in or leaning out? What happens with something that isn't answered in the docs, but is nearly answered in the docs? So you have to kind of make it. There's only a few of these you should make up, but we encourage our customers to do this all the time because they say, oh, we want to evaluate you and a load of agents. And we're like, okay, that's cool. But the fallacy or the worst evaluation we ever see is, I asked you and I asked Zendesk how to reset my password, and you both got it right. And I'm like, cool. That's like asking me and Einstein what's 2 + 2, and then concluding we're both great mathematicians. The actual differences show on the edge. We earn our money in the hard cases, not the easy cases. So I would say to anyone, and this is true for all of you, not even if you're buying CS agents, but actually as you're trying to demonstrate superiority in agents, you have to like be able to teach your customers how to understand the difference.
So sort of related to this, clearly the torture test plays a really big role in deciding whether a particular iteration of Fin is ready for prime time. What are sort of the other indications that you've achieved production readiness in a probabilistic environment? Like, how do you quantify this? How do you get to the point where you feel like this thing's ready?
Yeah, there's 2 other sort of product market fit type things. One is like, it's a very obvious one, but just like some sense of, does anyone give a shit? So like, so in the case of like Fin answering questions, of course everyone cares, and if it does a good job, that's great. It's more all the stuff we build around the edges of Fin. So we build a whole test suite where you can like do batch testing or like do deep testing of specific scenarios. Or we're about to launch a very, very cool new product next Wednesday, which is all around analysis of your customer support conversations. But you are looking for 2 things with these types of releases that are not like where the answer isn't that percentage goes up. You're looking for frequent engagement and like meaningful outcomes. So a lot of what we build is like it's supposed to help people get the most out of our product. So what we look at is, do they use it a lot? And then if they do, does it actually change their behavior? Ultimately, Fin is about getting you to like 100% AI resolutions, or as close as. We don't really believe you're going to get to 100. But if so, like what we look to do is like, hey, since we released that, has behavior gotten better or worse? So that's one thing. And the reason that sounds like that probably is at some abstract level true for all software, but just the mindset shift you have to have when you're building an agent is that you're trying to build something to do a job completely. So then you have to build all the peripheral software that helps you manage the agent or helps your customers manage that agent so that they can get it to do the job completely, and so that they can actually score it and say it's doing a good job or a bad job. Would they hire it or fire it? Would it get a promotion? Would it be on a PIP? You kind of have to equip your customers to understand all that. The other thing I'd say is agent behavior. Like basically, you can imagine in the wild world of support, you have like the Four Seasons has a different customer support policy to say like EasyJet or Ryanair or Southwest, depending on your budget airline, wherever you live, right? Like some and like basically different brands have different basically different LTVs of their customers, or they value their customers in different ways. So every time you bump into one of these sort of vectors of differentiation within your sort of customer set, you then have to create effectively preferences or settings for how the agent should behave. Now, a common thing people do is they say, oh, that's okay, we're just going to have one big ass prompt box and they can just write in everything they want. And that sounds really good, but it's impossible to maintain. Your customers are not prompt engineers. there's a right way to tell somebody to be quick and efficient, and there's a bad way to do it. And like, you know, if you expose like a kind of raw prompt to all your customers all the time, you'll get some bad behavior. Like it's every time you're giving your customer a large text area and saying some version of describe the behavior you want, you're kind of handing them a very sharp knife and crossing your fingers a little bit. So you end up having to distill these things down into sort of, ultimately you end up designing the feature, not just being like, you know, a la carte, you tell us what you want. It's almost like the Henry Ford thing. It's just slightly different. Customers want different things. It's your job to like identify the common traits of those things. So to give you one simple example, in Fin, we special case things like tone of voice, and we special case things like answer length, because there's a right way to tell Claude or to tell Fin, hey, here's the length of answer we want, and there's a stupid way. And so you could say, be really short, and what you'll get is a very rude agent. So you have to like kind of help your customers. But I do notice there's a tendency with startups to say, you can, you know, here's a big text box, you know, go nuts. And customers do go nuts, and then they think your product sucks. So that's the other aspect, is just make sure that you've kind of paved the common desire paths of behavior so that the customers don't have to work it all out themselves.
And how does that, I haven't been on the other side of your product. How does that manifest? Is it like documentation you give your customers, or is the customization UI sort of set up so that they can't get off the happy path? How do you do that? It's
the latter. So we do, you know, we just give you like literal, you know, buttons that say like, you know, what tone of voice do you want or whatever. And we recommend, like, we have a feature called guidance where you can add in your extra stuff on top. An example would be like, maybe like Airbnb wants to refer to their guests as like patrons, and maybe they want to refer to landlords a certain way, or like, you know, there's things like that. But the way in which we've built Fin, that's it's important where you apply that to the answer. You should generate the answer first, and then follow the guidance to adapt the answer to meet the, say, like the requirements of words or verbiage or whatever. However, if you kind of like let it go in raw, you'll set yourself up in a bad way. So ultimately what Fin is we know all the common things that companies differ on, and we give you all the options and preferences you need for that. And then there's an after the fact sort of, now, if you've any weird special rules, like maybe you call yourselves Teslians or something like that, we'll deal with that. Yeah, brilliant, exactly. We'll deal with that after, once we've generated a nice, concise answer that's humorous and happy, and it references these materials and that. Once we've got all that done, then let's apply your, frankly, like slightly less important stuff. You know?
Yeah. I had this existential moment, Des, listening to you, where we were talking about how do you sort of coax the LLMs to do just the right thing, and then we shifted to how do you coax humans to do just the right thing.
Yeah. You know, it's funny that conversation comes up a lot. Like I was discussing, so we have this feature called tasks where you can basically tell Fin, hey, here's how we do a refund, and you know, people measure it. You know, we care a lot about the reliability of these steps in a task, because like if something's only 90% reliable and you daisy chain 3 of those steps in a row, you're down to like an unperformant thing. This sort of the probability gap or whatever, compound. What's interesting is they're like, you know, I had a customer say to me, how do you get like these like slightly ineffective or slightly inefficient things to like work together, still deliver a required outcome? And I was like, have you ever been a manager? That's literally what it is. Like, you know, Johnny's hungover, Debbie didn't show up. We still need the system to work. You know, like like the nature of companies is there are ways to get these slightly unreliable agents to do things predictably and deliver some sort of common, consistent service to the world, you know?
Well, I think this is interesting time to talk about more of the interaction between the agent and humans. Let's sort of start out with, you talked about the success rate getting now, I think, to 58, 59%, which is, for those keeping track, I think is like a 10% boost since the last time we talked some time ago, like 9 months ago or whatever. What are the signals you look for when it's clear that you have to engage a human in the conversation? Do you just sort of, like when I deal with some online service providers, I won't mention names, I feel like I have to type agent.
Human.
How do you do it?
I mean, like, you know, the shortest answer is we actually ask you, hey, did this answer your question? And like, so like that's the most obvious. If somebody says anything other than like a positive answer, then that's an obvious route to agent. And we look for frustration. We look for like, as in frustration might emerge in the middle of a conversation where we think we're having a back and forth, but the person is either, you know, caps locking it or whatever. there's also like in the guidance feature I mentioned earlier, you can have like escalation settings, like, you know, if they mention scam or like hacked or whatever, always escalate. If it sounds like the user's being compromised, if it sounds like they're worried, if it sounds like, you know, you've all sorts of, like, every type of business has a specific hot button concern. Like if you're an online gaming company, you care a lot about people who, you know, say they're feeling very down after a certain bad beat or something like that. So you have to kind of special case every one of these with the guidance feature. But we generally look for like anything that suggests that the user, even if the user just starts a new conversation straight away, that's another negative sign. Anything that looks basically like wasn't a positive conclusion would be the beginning of a path to escalate. But to be clear, our default wouldn't be to immediately hand over to human, because that's not what customers want or what our customers want. What it will be is to ask, do you want to talk to a human? And then you'll say yes, and then you'll get over it. Because sometimes people will just go silent while they're clicking around the screen, and you don't want to be like, all right, here's John, he's going to solve your problem, like, because they're actually halfway through whatever answer you gave them. So.
And I imagine different customers of yours have different thresholds for how much they might be willing to sort of, I don't want to say antagonize, but sort of wait until they do the escalation to the human.
Absolutely. And they have different, like, they're kind of like different everything, honestly. Customers, I think customer service, a lot of folks don't respect it enough for how nuanced it is as a domain. I think it's one of these situations where if you work in one customer support org that might have like clean and simple rules, you might therefore be misled into thinking that it's therefore a clean and simple problem domain. But in practice, what it is this extremely large superset of, like, you know, probably hundreds of company preferences. And you have to kind of like work out a sort of happy path through all of them in your product offering. So yes, thresholds for when we should hand over, what we should hand over, how we should hand over, the delay before handing over. Do you hand over to a live agent, or do you hand over to an asynchronous follow-up? Do you want to hand over to a request a fallback, you know, or a callback? Like, all of those things are like in the mix here. And it's, yeah, you're kind of wading through a sea of preferences.
Talking about sort of the interaction between humans and the agent a little more, I imagine the stuff that gets routed to humans becomes more and more the edge cases, becomes more and more complicated. What does the shift do for job satisfaction of the humans involved? Do they tend to like their jobs more, or does it start to feel like kind of an assembly line grind where you only get like the grubby stuff that is really no fun?
I think it depends on it's kind of an issue of perspective. So I think what happens a lot is there's a few things people don't realize about customer service. One is it's a very transitional job because it's primarily entry level. So when you are thinking of a customer support agent, you should realize that almost by definition, that person is either just after starting the job or is just about to leave the job. That's it
was my first job coming into industry way back when.
Like, and that's a very common story. Like the amount of CEOs of our customers who say that they got their first start in CS or whatever. So it is like there's a tendency to be like, no, preserve those jobs. And it's kind of like that age-old argument of like, if we forced the construction companies to dig with spoons, we'd have more jobs, you know, but it wouldn't be good jobs. Like, you know, there's a reason why we invent technology and we try to move faster and better. So I think what we see is in practice, when you apply Fin and you get the 56% reduction, a few things happen. Like your first response time, which is a classic CS metric, that goes way faster because obviously Fin's very fast, but then your agents are less burdened as well, so they get a lot faster. Your average handling time, which is the previous sort of measure, again, an incumbent measure, that goes way up because your humans are only dealing with really hard stuff now. They're only dealing with the stuff that like wasn't in any way answered by any documents anywhere. So the complexity goes up, and ultimately what you see, the changes you see happen in a customer support org is there is sometimes it will either stays like relative to the support volume, it will get smaller, right? Or sometimes it actually shrinks itself. But certainly like what you see a lot of the time is they stop growing. The next change you see is there's a lot more specialization. So you get like, principal product specialist on a support team. And that like role is, usually higher paid, usually higher valued. There's a lot more expertise. And all of a sudden what happens is a career path emerges for customer support people where they can actually like use the fact that they've worked in this company for like 3, 4, 5 years. They really understand the product inside and out. They know all the edge cases, and now they can get paid for that because they're not spending half their day explaining how to reset passwords. They're actually putting all their time into like really high quality, like ultimately quite differentiated work. So that's the change. The other side of it is what we call like human in the loop. So the new kind of frontline support might be a bit more human approval processes. That can be a bit grunty or grindy, or like, as you said, like in that, like a classic step would be like approve this refund before it goes live. And the approval is, I just want a human to eyeball this to make sure that they haven't in some way exploited the bot or whatever, right? And so that would usually look like a human going, yep, the order, yes, it's late, and yes, that's that. Okay, click. And that work, again, it's like not, you know, it's there because there's a degree of trust or human validation that the business wants to enforce, and that will ultimately just be a queue or an inbox that you're just jumping through. I suspect over time people will find better ways to grow more trust and confidence in agents to handle that. But that's like, when you look at the sort of topology of a support team, you get a lot more specialists, a lot, frankly, fancier job titles, like and then you get people who own the agent and own the intelligence, because all these other changes happen. Like your documentation is now like mission critical infrastructure, because it's literally how your support works.
Yeah.
So all of a sudden you really care about that being really good and really reliable and really up to date, and it's worth investing in it. You've got people who own the automations for things like refunds or flight changes or baggage routes or whatever. Like whatever your business is, you have to have somebody who's in charge of Fin, if you like. So I think a lot of things change, but they're like, there's definitely an optimistic take here, which is like you know, if you've ever seen, like you mentioned you started it, if you've ever seen where these kind of like call centers look like, or where these live chat centers look like, it is not the job that like we, you know, there's a kind of a temptation to be like, oh no, protect them and keep them in their factories, they'll be happy there. I think that's the wrong way to think about it. I think what, you know, another argument is offer a really good career path from this. And yeah, maybe there's less total roles, but like if you look at humanities employment over time, we've always found stuff to do. Like I think I was joking with somebody recently where they were saying like, you know, like think about what the spreadsheet did to investment banking, right? One of my friends used to joke, you know, investment bankers used to be really busy before the spreadsheet got invented. And I'm like, all right. And it's not, you know, they're obviously still quite busy now. The spreadsheet, like the big fear of the spreadsheet was it would kill all the bookkeepers. And in practice, when you look at the numbers, it is true that there are less bookkeepers per business now than there used to be. But are there less people employed? No. Accountancy kicked off. All these other like analysts, financial analysts kicked off. All these other sectors emerged. They were like, you know, higher order, higher value. And I think that's the sort of thing you're going to see happen. So it's not really just about a net loss in jobs, to my mind. It's about like, you know, there is displacement. I don't want to lie about that. Like, you know, I can't be sitting here saying we're doing 56% and also there's no change. There will be some changes, but I think there'll be, you know, in a load of cases, remarkably positive changes.
Am I right to maybe even fantasize a little bit about new kind of high leverage jobs of the future where you have support agents, humans, who are kind of looking at what the agents are doing and sort of planning strategy and seeing new patterns emerge and sort of strategically engaging to sort of control this fleet of agents? I mean, that seems like a really cool job.
Well, and like that's coming, like as in, I wasn't going to like try and pitch anything, but like tomorrow week in London, we're literally having an event where we're launching the first product in that line of thinking, where you have a kind of a dashboard for seeing what's going on. And based on that, you can then make decisions about what else do I need to tell Fin, how can I equip Fin, etc. Can't say too much about it because we haven't launched yet, but like, you know,
this is not actually a clumsy sort of like pitch moment. This is like totally organic. This is so cool, man.
Yeah, it's like, but you know, I think that there is an interesting thread we've been pulling that a lot of your guests, or sorry, your viewers might be interested in, which is it's one thing to like agentify a job, whether it's like, you know, a coder, whether it's marketing copy, whether it's an SDR, whether it's customer support. The next thing you have to do is build all the surrounding tooling for the person whose job it is to set that up. So like, you know, just to make this not a pitch, let's just say if we take something like sales representative, like person who does sales live chat. If you nail that with an agent, that can really be a really persuasive sort of chat with a website visitor to sell them on a product. That's cool. The first thing your customers are going to ask is this working? How do I make it better? How do I improve it? How do I see what's going on so I can get better answers? And all of a sudden you have to build this like agent operating platform, which is like, you're kind of like your heads up display for what the hell's going on.
Yeah.
If you know, and so like there are all these like peripheral tools that go around the agent, which by the way, as a side note, is why it kills me whenever anyone gets into the discussion about thin wrappers or any of that. I'm just like, you don't realize how much software you have to build to like handle 50, 60, 70% of the support of a large company, you know?
Yeah, totally, man. So looking at time, I think we have another 12 minutes or so before the end of the session. So if any of you have questions to ask, go ahead and just enter the questions. We've got a team monitoring, and I'll interrupt the conversation to take your question, and Des will answer it. In the meantime, I'm just going to keep jamming with Des, and we'll keep going. So I want to pivot a little bit because in addition to the product you're building, I can't wait to see what you announce. That sounds amazing. I just wonder if you could give us some insights on how you use AI code-gen tools at Intercom. Like, are you using like tools like Bolt and Replit and Lovable and V0 and the like, or do you just sort of stick with sort of more sort of autocomplete type stuff? What is your stack, and what learnings do you have to share?
So we're about 500 people in R&D, maybe 100 in marketing. That's the areas where I know we have deployed AI mostly. All of our engineers by default are like Cursor or Windsurf. On top of that, we've layered on Claude Code is another common one. I think a lot of our AI group use that. And then like for what to me, like all of that is like perhaps slightly closer to the autocompletes. What I would say is most interesting for me is things like, say, Lovable as an alternative to Figma. So as an example, very related to the feature I just described, data visualization is extremely annoying to build out in Figma or any sort of design tool. Yeah. Like if you want to build like dynamic, adaptive, like, hey, understand these 25 conversations and plot sentiment on a bar chart or blah, blah. It's extremely wasteful to have like designers dragging and dropping various sized rectangles in a row or any version of that, right? And it's actually quite rewarding to think about Lovable or any of the equivalents, Create or V0 or whatever. If you think about them more as a wireframing tool than a final product tool in this exact case for a second, you can get really far by saying, right, we need to design a data visualization for a certain type of product or for a certain, like how would you visualize all of the most common topics and what the most frequent questions in those topics are? How would you visualize that? And you might say, oh, we could do like a tag cloud or a bubble diagram, or we could do like just a tree map, or like there are like loads of different ones. Now, right, like if we go back to 2021 or 2022 before ChatGPT drops, what actually happens there is people either start sketching or whiteboarding, or they wasted a lot of time dragging squares and circles around in a browser to try and visualize these ideas. We can now kind of explore the solution space for all possible visualizations realistically in like maybe 2 hours of just prompting, right? 2 hours of good prompting will get you like 10 or 12 different ideas that you can then look at and flick through and be like, which one of these makes sense? You can even feed it real data. And it, because it'll work, because it's actually live code. It's not like a perfectly dragged square. And you can look at these things and be like, I think item number 4 is up. And you can kind of pull a thread on that. Well, let's add some drop downs. What pickers would we need? What filters would we need? And you're doing all this. These are all design things. You're doing it in like a proper prototyping tool in Figma. Sorry, not in Figma, although Figma as of last week's releases might be relevant here. But like certainly V0, Bolt, Lovable, whatever. And you can kind of like, I often say, explore the solution space, which is like try out 10 different things and then exploit. So then when you've picked your version, you can then move into a different type of prompting, which is extremely deep refinement, which is where you can get to apply like, either like specific UI constraints or like art direction for the aesthetics or whatever. And you can get it a lot closer. You can give it all like the elements of your own UI. Like here's the typography we use. Here's our icon setting. It will work all that out as well. And then you can actually look at something that's a lot closer. Again, before we've asked an engineer to write a line of code, we can then be looking at something that's way closer. That's something you can then sit with an engineer and like you've kind of saved what could have honestly in the olden days been, weeks, if not months of like various different explorations and workshopping. You've reduced it to like a day, 2 days, 3 days sort of thing. And that's probably, for my mind, the single most impactful change that you should see in your software development lifecycle when you're properly AI enabled is the ability to explore and exploit should shrink from like weeks to like hours. Oh, cool. And if you do that right, because like I think I often hear engineers say this, like writing code as in like the fingers on keyboard piece is not the hard part. The hard part is you start building one thing and the designer changes their mind and the PM says, nope, sorry, that feature has to go in. And then if you had known that, you would have built it a different way. Like the whole process can be quite messy, but you can figure out so much extra shit in advance if you do proper prototyping.
Thank you for that. I want to come back to that with a question, but first I want to get to Martin Bishop's question. So Martin Bishop, thanks for your question. He asks, how much impact do you see when you change the underlying models?
So I would say up to like 25 to 50%, 57% or whatever today's figure is. I think like honestly only like 2 or 3% of that is attributable to like various different models. Like it's not massive. We partnered with Anthropic because we believe we have the best partnership with them, and they had the best models as per our torture test. But I think Fin is like it's not like a single shot agent. It's a subsystem of about 15 different processes. There's like a process for disambiguating. There's a process where, there's like obviously chucking, re-ranking, summarizing. Then there's like the heart of Fin. When you've sourced all, you've performed your RAG, you've done all of that. At the very heart is then this idea of answer this question. I think we have experimented with, say, open source ones. We've experimented with DeepSeek, etc. They're all slightly worse than our current setup. That's the result of doing like hundreds of A/B tests to perfect our current setup. But I think the agent, like say the actual model itself, is not as high a unit of leverage versus the actual, say, the agent architecture. That's a thing that we saw a lot of win in. So I think we're on our third major architecture of Fin at this point. Every one of them has been significant in terms of improvement to like the resolution rate. Prompts probably second. And then there's other like slightly peripheral things that aren't the pure AI stuff. Like our RAG engine is bespoke. Our re-ranker is bespoke. These are all things that we've actually perfected specifically for what we do. Some of this is because we happened to have we had a previous AI product, so we had a lot of these things ready to go already pretty tuned. And of course, back in the old days, you really had to tune them because the performance was so tough to get. So yeah, I think I'd say like, a lot of people think like, hey, like DeepSeek dropped, why isn't Fin going up or whatever? And we're like, well, because that's not where the meat of the problem is,
I'm imagining like you've sort of built a proprietary vertically specific reasoning model on top of whatever underlying LLM you have. And because of that, like all these other things are just very, very incremental to the reasoning you've built.
And that's not to say that they're insignificant. Like we fight for every one of these %, if you know what I mean.
Yeah, totally.
But you are correct. Yeah.
Interesting. So next question, Radhika asks, could AI coding tools be useful for less experienced developers to write more efficient and scalable code? That's an interesting one.
Yeah, I can't say this for sure. I can just give my opinion. I think the degree to which you can, you're like, one area I think a lot of teams don't spend enough time in is like before AI happened, we already had an R&D operations team, and one of the things they spent a lot of time optimizing was our developer environment. So we care a lot about this, and we had a team who focused on this already. I think when AI happened, a thing a lot of companies do is just like, hey, like, someone posts in Slack, hey, you should all go and check out Cursor. Anyway, back to work. And I think if you really want to get results, you need to kind of take a stronger opinion. So that looks like things like writing your as Gene, who was on the previous speaker, was saying, like, write your rules file or your Claude.md or whatever, like explain exactly the type of code you want. To some degree, it's also a function of, is your existing code base coherent, like, high cohesion, low coupling, blah, blah, blah. Like, is it easy? But so I would posit to Radhika's question, like, my suspicion is if your code base is pretty easy to learn and pretty easy to work with, what you'll find is like AI coding tools will be great for accelerating a new person's ability to contribute. If your code base is, let's just say, older, contains multiple different versions, has lots of different libraries, you're mixing all sorts of various generations of software together, then the chances are no, is my experience. And I think the challenge then becomes like, should you consider ultimately like rewriting parts of your product, like the core engines where you need to do most of your improvement? Should you think about rewriting from a point of view of getting them into shape so that the AI tools can help? That's the kind of a big question for a lot of orgs that they're facing right now. And it's worth asking, even though no one likes to say the rewrite word, but you have to bear in mind, like, your competitors who were started in the last 6 months, who were like born in some YC garage somewhere, They have none of your tech debt. They have none of your legacy bullshit. They're going to have the freedom to build all this stuff like natively in AI from the get-go. So no matter, you might think it's an advantage that you've got 7 years of coding and a 7 year of product work behind you. What they see is we're going to take 5 screenshots, feed it all to Claude, and tell it to write it using the latest and greatest, and we'll have all the features that you have now. And we got them in 2 weeks, and the AI knows how to improve on them. Does your AI know how to improve on it? And these are slightly existential, scary questions, but I think you have to kind of ask them to get proper kind of like situational awareness of what you're facing.
We have like a minute left, and I see this question. Let me just parse it for a second. Okay, yeah, maybe we can do this in like a minute or less, Des.
Sure.
Like, how are customers receiving Fin? Like, do you see customers being concerned with job loss and other things, or are people embracing the cost savings with open arms?
There's categories. So we have 5,000 customers or so. Revenues in like the tens of millions. It's growing very fast. The general response is it's a glass of ice water to somebody in hell, because a lot of customer support teams are extremely underwater. So the very second they turn on Fin, they kind of get their breath back and they can get through the backlog, and they're now finally their heads above water. That was Anthropic's experience when they started using it. Wow. That's the actual quote they gave us. They're like, it was the first time we actually got down to inbox zero in a customer support org. So that's one reaction. And in those cases, it's not like they're not thinking, oh, great, now we can right size our support team. They're thinking, finally, we can kind of get a handle on things. So that's a very genuine reaction. Sometimes if there's like a BPO, a business process outsource firm involved, their contract might not get renewed on the far side of all this. That's just natural. Like, they were brought in as a temporary thing. They leave as a temporary thing. In terms of our customers, some of the funniest reactions we see are things like a human takes over the conversation, and we'll see somebody say, sorry, I was actually doing grand with Fin. Could you put me back to Fin, please? And it's not that Fin's brilliant so much as they don't like the idea that they're bothering a human. It would be like as if you knew there was a human behind ChatGPT doing all the lookups based on what you said, you'd feel a lot more sympathy, and you'd be like, no, you know what, I don't need to bother you anymore. So there's a thing where people like the idea that there's a bot there to answer every question that they might otherwise have to look up,
Yeah, absolutely. Des, you've been so generous with your time. You stayed up late. You're here local in European time, UK time. Thank you so much for your time. This has been a really fun conversation for me.
I enjoyed it too, Ben. Thanks a lot. And thanks to everyone else who came along. Take care.
See you, Des.
Okay, thanks so much. That was a great way to end the track. What we'd like to do now is we've got an amazing keynote from the CEO of Netlify, who came up with the notion of AX, right? So we had UX, then we had DX, developer experience, and now Matt believes it's time for the era of agent experience, and he's going to talk through all of that. So what we'd love you to do now is to join the keynote stage. There'll be some more vibe coding antics going on while we set up the keynote with Matt of Netlify to talk about agent experience. So please join us for the final hurrah with the closing keynote. And thanks so much for being on the stream.